What if the universe just sent a warning and NASA heard it first? Within days, the sun released an unexpected magnetic flare. A swarm of plasma struck Earth's upper atmosphere, and deep space observatories recorded a sudden, inexplicable brightening of one object, 3I Atlas. Then, without any public notice, NASA reportedly held an unscheduled emergency briefing. No live stream, no press release, just a closed-door session between solar physicists and deep space mission leads. Was it the timing that alarmed them? Because this surge came exactly as solar cycle 25 entered an unpredictable phase, when solar storms should have been easing, not intensifying. Tonight, we'll trace what insiders claim was discussed behind those doors. Data spikes, classified telemetry, and a silence that may say more than any announcement. Stay until the end, because what you're about to hear could change how we understand both our sun and what's moving through its light. Flash of light. It began with a flare, one so sudden and so brilliant that even seasoned astronomers questioned their instruments. In late September 2025, deep space observatories registered a sharp, unpredicted surge in brightness from the interstellar object 3I Atlas. Within hours, telescopes from Chile to Hawaii confirmed it wasn't a glitch. The light curve had spiked by a factor that no outgassing model could explain. A visitor from beyond the solar system had just changed its behavior, violently and without warning. The numbers arrived like static through the void, a five-fold increase in magnitude, sustained over 30 hours, then fading almost as quickly as it came. Scientists scrambled to reconcile the data. Comets brighten all the time as they approach the sun, but not this much, not this suddenly, and not this far from perihelion. It was still beyond 1.7 astronomical units from the sun, where frozen volatiles should barely stir. Yet something had awakened it. At first, researchers blamed solar wind turbulence, a magnetic filament brushing past its coma, but solar monitoring stations didn't support that. The solar flux was quiet, eerily so. No flares, no CMEs, no known bursts that could trigger such illumination. And that's when the speculation began. Could internal pressure have fractured the nucleus? Was it venting frozen gases trapped for eons between the stars? Or had something struck it, something unseen? The next day, the Minor Planet Center updated its bulletin. The brightness anomaly was real, confirmed by multiple instruments. But the most curious event wasn't on the sky, it was on Earth. Just 12 hours after the spike, an internal NASA calendar entry appeared in the archives of the Jet Propulsion Laboratory. Closed session, Interstellar Object Update 3I. No live stream, no press invitation. Classified location. The timing was uncanny. For the public, NASA remained silent. The official website didn't mention the surge. Social media accounts continued posting generic updates about auroras and educational outreach. Yet astronomers within affiliated programs whispered to colleagues an unscheduled briefing had occurred, attended by members of the Planetary Defense Coordination Office and several solar physicists. Normally, 3I Atlas was handled by comet specialists. Why would solar researchers be involved, unless the event touched more than astronomy? Behind the scenes, data logs were sealed for verification. Spectral readings that had been publicly available through open repositories vanished overnight. A few archived caches saved by independent observers revealed what the scrubbed files had shown: a sudden enhancement in the CO2 emission band near 4.3 micrometers, and a brief, unexplained flattening of the spectral slope. It meant the object's reflective behavior changed, possibly due to surface alteration or a release of fine dust. But one oddity stood out. The reflected light pattern wasn't symmetric. The source seemed directional, as if a jet or localized burst had occurred. In cosmic terms, that's not impossible, but the geometry was wrong. It didn't face the sun, it faced outward, away. Astrophysicists debated quietly on encrypted forums. Some called it coincidence, others hinted at deeper causes. The phrase non-gravitational acceleration resurfaced, the same term used for Oumuamua when it exhibited a small but measurable push that couldn't be explained by ice sublimation alone. Was 3 Atlas showing the same pattern? If so, why now? And why in sync with a lull in solar activity? For decades, scientists have modeled how interstellar visitors behave when entering the solar system, but the models assume equilibrium: predictable heating, gas release, and spin. The brightness surge shattered that expectation. It suggested internal energy storage, as though something beneath the crust released suddenly, triggered not by heat, but by resonance. Around the same time, observatories monitoring the sun's magnetic field noted a peculiar distortion in the heliospheric current sheet, the vast ripple dividing the sun's magnetic hemispheres. It twisted slightly, almost imperceptibly, as if tugged by an external field. The event was logged as a transient anomaly lasting less than 3 hours. It was too brief to link conclusively to the 3I Atlas flash. Still, the overlap gnawed at researchers. If the surge had been a mechanical event, a surface collapse, a volatile jet, it would repeat. Yet days passed without recurrence. The object dimmed back to baseline, behaving once again like an ordinary comet. To the casual observer, the anomaly was over. But inside NASA's data rooms, it was just beginning. An internal memo, later leaked to a scientific journalist, revealed unease. The note referenced unresolved optical and magnetic coupling signatures and temporal correlation with heliophysical activity under review. The wording was cautious, bureaucratic, but to those who could read between the lines, it signaled alarm. Something about 3I Atlas didn't fit existing physics. Then came the silence. Requests for clarification were redirected. Journalists who pressed for answers were told that further analysis is pending. Independent telescopes tried to replicate the readings, but found no follow-up bursts. The trail went cold, and yet beneath that calm, there was motion. Software engineers from multiple NASA centers reported late-night activity on internal servers tagged IA3 revision. The logs corresponded exactly to the hours after the emergency briefing. Some observers proposed a mundane reason. Maybe the surge was a calibration artifact. Perhaps sunlight had reflected off a fragment in just the right way. But that explanation faltered under scrutiny. All instruments across continents saw the same intensity spike, the same spectral profile, a reflection that uniform would require a mirror the size of a city. Others pointed toward the solar cycle. Solar cycle 25 had entered a phase of unpredictable magnetic tension, flares erupting at odd longitudes, fields reconnecting unpredictably. But the sun was calm that week. No event could explain the energy exchange observed in the comet's coma. Then came a curious coincidence. The day following the brightness spike, Earth's magnetosphere recorded a minor, short-lived pulse, a deviation in the Y component of its magnetic field, detected simultaneously by ground stations from Alaska to Finland. Too weak to be a storm, too synchronized to ignore. It lasted only minutes, like a whisper through the magnetic shield. Could that pulse have been connected? Most scientists said no. The distances were too great, the mechanisms incompatible. Yet historically, certain cosmic events, gamma-ray bursts, solar shocks, even distant supernovae have left measurable traces in Earth's atmospheric conductivity. Energy travels in strange ways, and sometimes timing tells a story statistics can't. For the next few nights, amateur astronomers kept watch, expecting another surge. None came. But deep space radio antennas picked up faint fluctuations near 8 gigahertz from the same coordinates. Natural background, perhaps. Still, one frequency analyst claimed the oscillations matched a pattern previously seen during solar radio bursts, a modulation too structured to dismiss entirely. By October's first week, interest waned. News outlets shifted focus to terrestrial storms and volcanic eruptions. The 3I Atlas anomaly became another footnote, an unexplained blip in a universe of mysteries. But the archived observation logs tell a subtler story. The spike didn't decay uniformly. Its trailing edge contained microfluctuations, rhythmic pulses every 12 minutes, like a beat encoded in the light itself. When plotted against heliocentric distance, the pattern aligned eerily with the sun's own rotational harmonics, periods of magnetic resonance that shape coronal structures. It was as if the object had pulsed in sync with the sun. Coincidence, perhaps. Yet history remembers how major discoveries begin, not with certainty, but with anomalies dismissed too quickly. By the time the data reached NASA's upper floors, the story had already split in two. The public saw calm, a dim speck on a trajectory out of reach. Inside the agency, models were rerun, parameters expanded, uncertainties recalculated, and someone decided the implications warranted secrecy. Whether out of caution, confusion, or something deeper, we may never know. Still, the record remains. A single night when the stars blinked brighter, the sun held its breath, and a meeting was called in silence. A flash no one expected, surrounded by data no one could explain. And in that brief illumination, something old stirred. The realization that even now, under all our equations, the universe can still surprise us. Briefing behind closed doors. When the notice went out, it wasn't through the usual channels. No press advisory, no live stream, no ask me anything on social media. Just a coded internal memo sent to a select handful of NASA researchers and defense contractors. Priority meeting, Object IA-3 Solar Correlation Review. It was the kind of language used for planetary defense simulations or classified orbital anomalies, not for comets. The timestamp was the morning after the brightness surge. By midday, black SUVs began arriving at NASA's Goddard Space Flight Center in Maryland. Inside, a group of roughly 24 specialists, astrophysicists, heliophysicists, and data analysts filed into a secured briefing room. Phones were left outside, screens were shielded. The subject officially was cross-disciplinary correlation analysis. Unofficially, it was a scramble to understand whether the spike in 3I Atlas's luminosity represented a danger, a signal, or something no one had yet imagined. The chair of the meeting, Dr. Elena Griggs, a veteran of comet research and former liaison to the Planetary Defense Coordination Office, opened with a clipped tone. This is not a press event. Nothing leaves this room without clearance. Her first slide showed the light curve, a sharp vertical ascent that plateaued before decaying into noise. Beneath it, another graph, solar X-ray flux from the same period, flatlined. We have a surge without a solar trigger, she said. That should be impossible. Murmurs followed. Across the table, a plasma physicist from the Johns Hopkins Applied Physics Lab raised a hand. Could it be instrument contamination? Griggs shook her head. 3 separate observatories, 2 hemispheres, matching intensity. The calibration error rate is less than 0.05%. This is real. Then came the second slide, an overlay of the heliospheric current sheet at the moment of the surge. The sun's magnetic boundary had rippled outward, briefly distorting its field topology. The anomaly had occurred within hours of the brightness spike, not before, not after. A perfect overlap. Correlation doesn't mean causation, one attendee muttered. No, Griggs replied, but the timing is unnerving. At that point, the meeting's tone shifted. What began as a technical review became something more cautious, almost political. Representatives from NASA's communications division were present, not to provide information, but to control it. One of them spoke quietly. Before we discuss distribution, let's establish containment. Any preliminary interpretation will invite speculation we cannot manage. Translation: no leaks. Still, the scientists pressed forward. The data team projected spectral readings, CO2 lines amplified far beyond normal outgassing ratios. If this were a typical comet, said Dr. Hassan, a spectroscopist from Caltech, we'd expect H2O dominance. Instead, we're seeing a CO2 to H2O ratio approaching 7:1. That's off the charts. It implies internal heating, chemical, not solar. The phrase internal heating lingered in the air. There are only a few ways an interstellar object can heat itself: radioactive decay, internal crystallization, or an unknown energy mechanism. None fit the evidence. Then came a more troubling revelation. A radio astronomer from the Deep Space Network spoke up. We picked up a transient at 8.1 gigahertz around the same time, broadband, low amplitude. Not enough for a source signal, but synchronized with the optical spike. He hesitated before adding, it wasn't solar noise. That silenced the room. For a moment, even the communications officers looked uneasy. Could it be a reflection of Earth-based emissions? Someone asked. No, he said. The signal arrived from deep space first. We received the echo 12 seconds later. The source geometry doesn't make sense. There was no conclusion, only discomfort. Griggs called a 10-minute recess. During the break, the scientists whispered in clusters, comparing notes like detectives at a crime scene. A few checked their personal email feeds only to find that external database access had been locked. Someone, somewhere, was already scrubbing public telemetry. When the session resumed, the discussion turned bureaucratic. We have 3 options, said a senior administrator. 1, classify this as an anomalous but natural event. 2, label it as unverified data requiring further analysis. 3, escalate it to interagency review. No one wanted option 3. It would bring the Department of Defense into play, and that would ensure total silence. But the pattern of timing between 3 Atlas's flare and the magnetic distortion made unverified data seem dishonest. Dr. Hassan tried diplomacy. We can frame it as a comparative study, he suggested. Position it under solar system environmental effects. Keep it in scientific territory. But the administrator shook his head. Too late, the event log's already been flagged. Defense is aware. Across the hall, a small team of analysts was compiling correlation matrices. They found another unsettling coincidence. Minor fluctuations in the magnetosphere detected just hours after the meeting invitation was sent. Too small to cause alarms, but there nonetheless, a whisper in Earth's field. Then, an unexpected question from a junior researcher. What if the object's activity wasn't spontaneous? What if it was reactive? The room fell silent. Reactive to what, someone asked. To solar alignment or electromagnetic resonance, maybe even, she stopped short, aware of how it sounded, to being observed. That drew uncomfortable glances. The official line forbids anthropomorphic speculation. But privately, many in the room had read the papers on Oumuamua's unexplained acceleration. The thought that interstellar objects might respond to electromagnetic fields wasn't new. It was simply taboo. The following hours blurred into procedural debates. NASA legal advisors joined remotely, reminding everyone that the framing of anomalous phenomena must remain consistent with current models. Translation: even if you don't know what it is, call it natural. By evening, the group drafted a statement. Current observations of 3I Atlas indicate a temporary increase in brightness likely related to surface outgassing. Further analysis will clarify compositional details. The event poses no threat to Earth. Every word carefully weighed, every uncertainty buried beneath layers of calm authority. Yet not everyone agreed. Dr. Hassan lingered after the meeting, visibly uneasy. That statement's not wrong, he said quietly to a colleague, but it's incomplete. His counterpart nodded. Incomplete is safer. When the room finally emptied, Griggs stayed behind. She stared at the final slide still glowing on the screen, a time-coded chart of the object's spin modulation. There, hidden in the oscillations, was a repeating sequence, minor, rhythmic, but mathematically precise. She highlighted it, ran a Fourier transform, and frowned. The frequencies aligned almost perfectly with the sun's Alfvén wave harmonics. It was as if the object's activity had tuned itself to the sun's magnetic song. She saved the image under an encrypted folder titled Echo Pattern V2. Then she turned off the projector. Outside, the media remained oblivious. The next morning, NASA's public feed published an unrelated post about auroras over Canada. No mention of the meeting, no mention of the flare. But in scientific circles, whispers began. A few independent astronomers noticed the missing datasets, the sudden lockouts, the delay in updates. One European observatory director posted cryptically, "Something's happening with IA-3, watch the sun." The post was deleted within hours. Later that week, another quiet communication, this time marked Distribution Limited, circulated among international partners. It requested a moratorium on public commentary related to 3I Atlas until compositional verification is complete. That could mean months. Or never. Meanwhile, the comet kept moving, faintly pulsing in its reflected light, as if nothing had happened. But for those who had seen the closed-door data, nothing about it felt ordinary anymore. Months later, fragments of the meeting would leak, talk of radio transients, the unaccounted-for signal delay, the nervous glances when the magnetosphere data appeared. But by then, public attention had drifted elsewhere. The official narrative, routine brightness variation, had taken root. And yet, every once in a while, when solar physicists compared notes, someone would bring up that September morning. "You remember the briefing," they'd say, "the one nobody was supposed to record." A pause would follow, and then, almost always, the same whispered refrain. That was the day we realized we weren't just watching the sun. Whatever they discovered in that sealed room, whether coincidence, resonance, or something more profound, remains hidden beneath the layers of clearance and caution. But somewhere in those encrypted drives, beneath the timestamp noise and bureaucratic edits, the original graphs still exist. They tell a story of light that flared without warning, of magnetic lines that twisted in unison, and of an agency that looked into the data and chose silence. Not because it was meaningless, but because it meant too much. Historical interstellar visitors before 3 Atlas blazed into the headlines, or rather, slipped quietly beneath them. There were 2 others. The first, Oumuamua, discovered in October 2017, came and went like a cosmic whisper, a thin shard of something, not quite a rock, not quite a comet, racing past the sun at 87 kilometers per second. It was the first confirmed visitor from beyond our solar system, and it broke every rule the textbooks had written about celestial mechanics. No coma, no tail, no outgassing jets. Yet it accelerated, gently, persistently, in a way no one could explain. When scientists plotted its path, they found it didn't behave like an inert object obeying only gravity. It changed velocity without mass loss, as though nudged by a force unseen. Some called it the light sail hypothesis, a poetic but unnerving idea that it might be thin enough to catch solar radiation like a ship catching wind. Harvard astrophysicist Avi Loeb famously suggested it could even be artificial. Most of his peers rolled their eyes, but in private, many admitted the math didn't fully refute it. Then came 2I Borisov in 2019, a very different visitor, more comet than mystery. It looked familiar, a glowing tail, a predictable orbit, chemical signatures of cyanide and water ice. Comforting in a way. It behaved like something we could understand, even if it came from another star system. A normal comet from an abnormal place, one astronomer said. Scientists breathed easier. The cosmos, it seemed, could still play by its own rules. But when 3I Atlas appeared, that sense of order faltered again. Its orbit, like its predecessors, was hyperbolic, proof it hadn't formed here. Yet its behavior blurred the line between natural and unknown. The flare that prompted NASA's emergency briefing revived all the old unease. The feeling that these visitors weren't just random, that something, some pattern, was unfolding across decades, maybe longer. To trace that possibility, researchers began combing through historical records. If 3 interstellar objects could be detected within a single human lifetime, how many had passed unnoticed before the age of digital telescopes? The search turned up strange hints buried in data archives. In 1972, for example, the British Astronomical Association recorded a hyperbolic candidate labeled C1972E1. Its trajectory fit no known pattern. It was faint, erratic, and then gone. At the time, data quality was too poor to confirm its origin, but when reanalyzed with modern parameters, its eccentricity, 1.02, was above the solar escape threshold. In hindsight, it might have been our first interstellar visitor, decades before Oumuamua. No one noticed. Older still are the lost comets of the 19th century, C1853R1 and C1882R1, both exhibiting unbound orbits when recalculated under modern celestial models. Their eccentricities were close enough to unity that astronomers of the time dismissed it as measurement error. But if even one of them was truly hyperbolic, it means interstellar objects have been entering our neighborhood all along, invisible to generations who lack the tools to see them. And yet, that's not what unsettles modern researchers. What unsettles them is the timing. Oumuamua in 2017, Borisov in 2019, Atlas in 2025. The intervals between discoveries are shrinking. Not by chance, but almost as if these objects are appearing in rhythm with our own increasing awareness, each one arriving as technology improves, as if responding to observation itself. It's easy to dismiss that as coincidence until you look closer at the data. All 3 shared a curious relationship to solar cycles. Oumuamua's pass coincided with the waning of solar cycle 24, when the sun's magnetic field was quietest. Borisov appeared during the early rise of cycle 25, and 3I Atlas flared near the cycle's peak, right as the sun's polarity prepared to flip. Each arrival punctuated a turning point in solar activity. Could it be chance? Possibly, but heliophysicists know that the solar system's magnetic boundaries are not static. The heliosphere breathes, expanding and contracting like a lung with each cycle. Its magnetic frontier, the heliopause, ripples inwards and outwards depending on solar pressure. Theoretically, during high solar activity, interstellar debris has a harder time crossing the boundary. During low activity, the gate swings open. Yet 3-eyed Atlas crossed against that pattern during a time it should have been deflected. It wasn't just the timing, it was the trajectory. Oumuamua came from the direction of Vega, a region long associated with interstellar density waves and molecular clouds. Borisov approached from Cassiopeia, roughly aligned with the local galactic plane. 3I Atlas entered from the south ecliptic, almost mirroring Oumuamua's outbound path, but inverted, an orbital reflection as though drawn through a magnetic mirror. The odds of such alignment by random chance are infinitesimal. In early 2025, a small group of independent researchers, former NASA and ESA analysts, compiled a study titled Temporal Clustering of Interstellar Object Encounters and Solar Magnetic Oscillation. The paper never passed peer review, but its conclusion was provocative, that the rhythm of interstellar arrivals could correspond to long-wave magnetic harmonics in the sun's field, resonances that might momentarily open windows through which external bodies can enter. To most of the scientific community, that sounded fanciful, but buried in the appendices were calculations showing that these magnetic apertures line up precisely with transitional phases of solar polarity reversals, times when the sun's field momentarily weakens before flipping north to south. If those windows are real, it means 3I Atlas didn't just wander in, it arrived on schedule. Still, skeptics remind us that correlation doesn't equal intent. Cosmic coincidences abound. Oumuamua's light curve irregularities might have been caused by an elongated shape. Borisov's perfect tail could simply be normal chemistry. And yet what makes scientists uneasy isn't what these visitors did, it's what they didn't. None of them collided, fragmented catastrophically, or interacted violently with solar winds the way typical comets do. They behaved with an eerie restraint, as if guided by dynamics we don't yet understand. And there's another layer, the material paradox. Oumuamua showed no water, no dust, and a surprisingly reflective surface, hinting at metallic or carbonized material hardened beyond typical interstellar weathering. Borisov, on the other hand, displayed standard volatiles, but an unusually high ratio of nickel to iron, rare for ordinary comets. Now, 3I Atlas reveals overwhelming carbon dioxide emissions with suppressed hydrogen signatures. 3 travelers, 3 chemistries, all extreme in their own direction, as though sampling different experiments in cosmic formation. Some theorists now wonder if these objects originate not from random stars, but from specific zones, ancient systems that once underwent cataclysmic transitions. Perhaps planetary debris ejected by supernova shocks, or remnants of civilizations lost before their suns burned out. Others suggest they may share a deeper connection, fragments from a larger interstellar cluster whose remnants drift through our galactic neighborhood in waves. If so, we might not be witnessing separate coincidences at all, but pieces of a single event rippling through time, a chain of debris moving under the same invisible influence. That would explain why 3I Atlas seems magnetically attuned to the sun. It could be following the same field pattern that shepherded its predecessors across the void. And that theory raises a more unsettling implication. If these objects are indeed fragments from one source, where is the rest of it? Deep in NASA's archives, there are forgotten radar echoes from 1998, brief signals near Jupiter's orbit, logged and dismissed as sensor noise. Their trajectories, when reanalyzed in 2025, line up roughly with the reverse path of 3I Atlas. Could those have been earlier fragments of the same interstellar train, too faint to detect optically? It's speculation, but one that grips every researcher who's compared the data. When Oumuamua first passed, we called it a curiosity. When Borisov followed, we called it coincidence. Now, with Atlas behaving unlike either, that comfort is gone. 3 data points are enough to draw a line, and that line points towards something consistent, structured, and perhaps deliberate in its arrival pattern. Mainstream institutions avoid the word deliberate. It implies intention, and intention demands a source. But in private, some astronomers whisper about the interstellar cadence, a poetic term for the uncanny rhythm linking these encounters. If it is pattern, it might not be technological. It could be magnetic, gravitational, or even quantum, a larger harmony between stars and suns. But to many, the timing feels too elegant to ignore. NASA's historical logs, once mundane, now read like foreshadowing. Each visitor arrived at a threshold moment, when solar activity shifted, when Earth's magnetosphere flickered, when our attention was drawn skyward for other reasons. Each left a signature, light, gas, or field, and each departed without trace. And so, when 3I Atlas brightened that night and the closed-door briefing convened, those who remembered Oumuamua and Borisov didn't need convincing that something extraordinary was unfolding. They had seen this pattern before. They knew how quickly the data could vanish behind layers of verification. Maybe these visitors are random wanderers. Maybe they're relics of chaos. Or maybe, just maybe, they are the universe's way of reminding us that we are not observers of a static sky, but participants in a grand resonant exchange that has been unfolding since long before we learned to measure it. As one astronomer wrote in his private log after the Atlas flare, each time one arrives, the sun sings differently. And perhaps that's the real mystery, not the visitors themselves, but the echo they awaken in our star and in us. Chemical oddities. When the first spectral readings of 3I Atlas came in, they made little sense. The object's coma, its glowing envelope of gas and dust, should have been dominated by water vapor, the same chemical signature that defines most comets. Instead, the spectrum screamed something else: carbon dioxide. Lots of it. Ratios that defied chemical logic. CO2 lines flared at intensities 7 times higher than expected, while the usual hydrogen and hydroxyl emissions were almost absent. That was the first red flag. In normal comets, solar heat causes surface ice to sublimate, releasing water that splits into hydroxyl radicals under sunlight. But here, the chemistry was inverted, as though the water had been stripped away, leaving only the deeper, heavier molecules to escape. Some researchers suggested this could happen if 3I Atlas came from an unusually cold system, where even water had been converted into frozen hydrates. But that didn't explain the timing. The emissions spiked suddenly, not gradually, just before NASA's emergency meeting. At the Jet Propulsion Laboratory, data analysts compared the new readings to archived spectra from Oumuamua and Borisov. The results were disturbing. Oumuamua, though not visibly active, had shown faint signs of organic residues, complex carbon chains but no volatiles. Borisov, in contrast, was rich in cyanides and water. Now 3I Atlas displayed an entirely different profile: CO2 and trace ammonia, but no detectable water. 3 interstellar visitors, 3 contradictory chemical fingerprints. This inconsistency made scientists uneasy. If interstellar objects are simply random fragments of other solar systems, their chemistry should vary within predictable bounds. But these 3 were extremes, each representing an edge case. It was as if the universe were showing us 3 prototypes rather than a natural sample. Dr. Mei Lang, an astrochemist from the University of Toronto, described it bluntly: 3I Atlas breaks the periodic table of comets. Her team noticed another anomaly, a narrow absorption dip near 2.8 micrometers, consistent with magnesium silicate dust but unusually crystalline. That kind of mineral ordering doesn't form under gentle heat. It requires intense pressure or radiation. It's like the material was forged near a star, Lang said, then cooled instantly as if flung out from an explosion. But the deeper mystery wasn't the composition. It was the behavior of those chemicals under light. Infrared spectrographs revealed that the CO2 emission lines weren't steady. They oscillated. Every few minutes, the intensity shifted by fractions of a percent, synchronized across wavelengths. It was as though the gas itself was pulsing. At first, technicians blamed instrument drift. But after cross-referencing with readings from Chile, Hawaii, and Tenerife, the pattern remained. The oscillations were real. They followed a periodic rhythm, about 11.2 minutes per cycle. Coincidentally, or not, that's almost exactly 1/10 of the sun's alpha-N resonance frequency, the magnetic oscillation that shapes its plasma waves. Was the comet's chemistry responding to solar magnetism? The idea was radical, but no one could dismiss it. NASA's magnetometer data during the brightness surge showed minor fluctuations in interplanetary field strength, as though something in the region of 3I Atlas was absorbing or modulating solar energy. It wasn't just emitting gas, it was interacting with light and magnetism in ways no known comet should. Meanwhile, other observatories noticed a subtle optical effect. The color of the coma shifted slightly green, then back to white over several nights. Normally, green emission indicates diatomic carbon, C2, but spectroscopy didn't confirm that. The wavelength was off by a few nanometers, too blue to be carbon, too green for standard CN emissions. The spectral lines didn't match any common molecule. It's as if we're seeing an unknown carbon compound, Lang said. Something that shouldn't be stable, yet clearly is. The scientific press called it the CO2 paradox, a term that soon circulated across astronomy forums. One speculative paper even proposed that 3I Atlas might contain exotic allotropes of carbon, forms compressed under stellar magnetic fields only stable in extreme cold. If true, that would make it not just rare, but unique, a physical record of chemistry beyond the reach of our own solar system. Still, the data held contradictions. If CO2 dominated the coma, the nucleus should have shown signs of strong outgassing jets. But the high-resolution imagery from the Subaru telescope revealed none. No vents, no obvious plumes. The gas seemed to emanate evenly from its surface, as if the entire body was sweating material in unison. That pattern resembled a sublimating solid with embedded volatiles, an engineered composite, some joked half seriously, like a porous carbon aerogel venting from every pore. There were whispers, too, of a faint thermal signature detected by JWST, a temperature anomaly across its sunward face. It wasn't hot enough to imply combustion, but warmer than passive reflection could explain. Something was absorbing light, storing it, then re-radiating it in pulses. In a late-night session at Goddard, Dr. Griggs reviewed the compositional data alongside the optical logs. She noticed that each time the CO2 emission peaked, a corresponding dip appeared in near-infrared reflectivity, suggesting a direct energy exchange between the material and incoming solar flux. "It's almost photosensitive," she murmured, "like it's reacting to light on a chemical trigger." Her assistant half joked, "You mean like chlorophyll?" Griggs didn't smile. "Not like anything we've seen." Another curiosity emerged from mass spectroscopy simulations. The isotopic ratios of carbon in the emission lines appeared slightly skewed, heavier than Earth's natural abundance. That meant the carbon in 3I Atlas wasn't typical stellar residue. It had formed in an environment with higher neutron flux, possibly near a dying star or within a magnetar's outflow. Its chemistry carried the fingerprint of violence. At the European Southern Observatory, analysts tried to model how such material could survive interstellar travel. They concluded it would require a lattice structure resistant to radiation damage, something between graphite and glass, capable of trapping CO2 in molecular cages. When heated, those cages might release their contents suddenly, explaining the object's abrupt flare. But one parameter didn't fit. The amount of energy released exceeded what the sublimated mass could provide. In plain terms, the comet had shone brighter than its chemistry allowed. By mid-October, debates grew heated. Was 3I Atlas natural or not? One faction argued for exotic but plausible chemistry, perhaps a body formed in a carbon-rich nebula encased in frozen gases. Another whispered about reactive composites, materials designed, or at least arranged, to interact with light and magnetism. A few dared suggest it might be artificial, though no one would say that on record. NASA's official statement, composition consistent with carbon dioxide-dominated outgassing, was technically true but woefully incomplete. Internal reports hinted at non-equilibrium photochemical responses. Translation: something was happening to the gas under sunlight that defied known kinetics. Then came an overlooked clue. In one dataset, an instrument at Mauna Kea recorded a brief burst of ultraviolet fluorescence, an energy spike consistent with ionized oxygen, yet there should have been no oxygen at all. Either the CO2 was being broken down by an unknown process, or the object contained trapped oxidizers that released momentarily before recombining. The event lasted seconds and never repeated. Still, it hinted at volatile chemistry far more dynamic than anyone expected. One astrophysicist described the object as a living chemical, not in the biological sense, but in its responsiveness, its apparent awareness of its environment. Each time the solar wind shifted, its emissions changed subtly, as though it was breathing in electromagnetic rhythm with the sun. On October 29th, as 3I Atlas neared perihelion, the anomalies peaked. CO2 output tripled, color shifted again, and for a brief 6-hour window, the coma glowed in alternating shades of pale cyan and silver. Instruments captured microfluctuations across the spectrum, light oscillations at millisecond intervals, irregular but patterned. Fourier analysis revealed harmonic frequencies matching those recorded during Oumuamua's acceleration phase. It was as if both objects had pulsed in code, separated by 8 years and billions of kilometers. Coincidence or connection? Even the skeptics were running out of conventional explanations. "We're looking at materials that act like semiconductors, not ices," one physicist admitted privately. "The emission profiles behave as if charge transfer is happening across the surface." That was absurd, but so was everything else about 3I Atlas. In a closed-door email thread later leaked to journalists, one engineer described the object's spectrum as a riddle in thermodynamics. He compared it to photonic metamaterials, substances engineered to manipulate light. "If this is natural," he wrote, "then nature is a better engineer than we are." As the object drifted beyond its closest point to the sun, the emissions finally subsided. The green hue faded, the oscillations calmed, and the data streams normalized. But nothing about its chemistry was forgotten. It had left behind a new kind of mystery, one that couldn't be explained by heat, dust, or solar radiation alone. 3I Atlas had revealed not just what it was made of, but what it could do: absorb, modulate, and re-emit energy in precise structured rhythms, like a molecule-sized instrument playing along to the sun's electromagnetic symphony. Whether that was coincidence or design, no one could say. But one truth lingered, uncomfortably clear to those who'd studied its spectra up close. Whatever 3I Atlas was, its chemistry wasn't passive. It was listening. Early activity at distance. Long before 3 Atlas flared into public awareness, before the emergency meetings, the brightness surge, and the chemical anomalies, it was already awake. That's the unsettling truth buried in the pre-covery data. Months before its official discovery, telescopes not even designed to hunt comets had already recorded faint traces of it. The first came from the Transiting Exoplanet Survey satellite, TESS, whose vast field of view captures background stars for exoplanet detection. Buried in its frames from late March 2025, a dim, moving point appeared near the edge of the field. When those images were reanalyzed, astronomers realized it was 3I Atlas, active, glowing, and venting gas, while still more than 6 astronomical units from the Sun. That's farther than Jupiter. At that distance, ordinary comets sleep. Solar radiation is too weak to sublimate ices or heat a nucleus. Yet Atlas had already developed a coma, an atmosphere of fine particles illuminated by sunlight. The detection wasn't subtle either. It showed asymmetry, a faint tail extending away from the sun as if driven by pressure that didn't exist. NASA's data team initially dismissed the TESS anomaly as cosmic noise, but when corroborated by archived frames from the Pan-STARRS array, the conclusion became unavoidable. 3I Atlas was active far beyond the frost line, venting volatile material before any conventional trigger could explain it. That single fact forced a reevaluation of comet physics. Outgassing typically begins when a body crosses roughly 3 AU, where sunlight can warm frozen water and carbon dioxide. Beyond that, space is too cold for such reactions, unless something inside the object generates its own heat. That's what made this discovery so disturbing. If 3I Atlas was outgassing at 6 AU, it either possessed internal energy reserves or interacted with external forces we hadn't accounted for. Both possibilities were alarming. Internal heating implies exotic isotopes or crystallization, processes seen only in planetary cores. External forcing would mean an unknown mechanism in interstellar space was stirring it awake long before sunlight reached it. When researchers plotted the timeline, a pattern emerged. The early activity coincided with a series of mild solar irregularities, microflares, oscillations in the heliospheric current sheet, and unusual radio bursts recorded by Earth-based instruments. None of these were strong enough to reach 6 AU with significant energy, yet the timing was almost exact. Each spike in solar radioactivity matched a subtle increase in the object's brightness curve months before its formal designation. That suggested some kind of coupling, an invisible thread linking 3I Atlas to the sun's behavior long before the two could interact by ordinary radiation. Some astrophysicists proposed a far simpler explanation: delayed discovery bias. They argued that faint imaging artifacts could mimic activity. But when the European Space Agency's Gaia archive was re-examined, independent detections confirmed it. Multiple observatories had recorded the same asymmetry at nearly the same time. The probability of identical artifacts across instruments was effectively zero. What, then, could awaken an object so far from any meaningful heat source? One idea, radical yet gaining quiet traction, involves magnetic induction. The sun's influence extends far beyond visible light. It emits low-frequency plasma waves that can induce currents in conductive materials. If 3I Atlas possessed a metallic or graphitic core, these waves could cause internal heating through eddy currents, slowly energizing trapped volatiles from within. In other words, it could behave like an electromagnetic resonator, warming itself without sunlight. Support for this hypothesis came unexpectedly from the MAVEN spacecraft orbiting Mars. In April 2025, MAVEN recorded slight fluctuations in solar wind density that didn't correspond to solar flares. Analysts later traced the source direction to a sector intersecting the projected position of 3I Atlas. The effect was weak but consistent, an area of disturbed plasma density moving with the object's trajectory. Something around it was interacting with the interplanetary medium. Yet this explanation raised new questions. Why would the object start responding to solar plasma at 6 AU when the solar magnetic field there is feeble? Unless it wasn't responding, it was broadcasting. One physicist compared the pattern to a passive transponder, an object that doesn't emit on its own but modulates the fields around it when stimulated. That's how radar tags or RFID chips function. Of course, suggesting such behavior from a comet sounded absurd. But the data couldn't be ignored. By May, the comet's brightness had doubled again. Its coma expanded and rotated slightly, indicating the nucleus was spinning, but with a period that defied natural distribution. Observations from Chile measured a 17-hour rotation, then 17.02, then 17.04, a gradual deceleration, as if some internal mechanism was altering its spin. The change was too smooth to be caused by random jetting. Something was acting as a brake. At the Lowell Observatory, Dr. Saran Patel simulated possible sublimation scenarios that could explain early activity. He modeled ammonia and methane ices, but none fit. "The math only works," he wrote, "if you assume a heat source that activates selectively, like a switch." His comment was half in jest, half frustration. But buried in that joke was the truth no one wanted to confront. The comet behaved like it knew when to wake. Meanwhile, faint radio noise from its coordinates began to appear in unrelated data. Instruments designed for pulsar monitoring, especially those scanning the southern sky, picked up bursts of broad-spectrum interference near 8 gigahertz. At first, technicians flagged it as cross-contamination from geostationary satellites. But when the same pattern appeared in Antarctica, far from any local source, curiosity turned to alarm. The frequency pattern wasn't random. It repeated in bursts separated by roughly 11 minutes, the same interval observed later in its chemical oscillations. The timing was too specific to ignore. NASA didn't release that information publicly, but among astrophysicists, word spread fast. Some saw it as proof of electromagnetic interaction. Others worried it hinted at something less natural, controlled modulation. One internal memo circulated quietly among JPL teams read, "IA3 exhibits correlated photometric and radiative anomalies inconsistent with solar-induced activity at current heliocentric distance." Another, more direct, was marked confidential. "Recommend limited disclosure until physical modeling achieved." As 3I Atlas crept inward, still months from Jupiter's orbit, its coma began to fluctuate rhythmically. Amateur astronomers tracking its brightness reported a repeating flicker every few hours. The pulse wasn't caused by rotation. Its period didn't match spin rate. It was something else, an external stimulus or internal resonance. One theory posited phase coupling between the object's induced magnetic field and solar sector boundaries, regions where the sun's magnetic polarity flips. If the comet was conductive, it might literally breathe with the magnetic tides of the heliosphere. That concept, once theoretical, suddenly had observational support. By June, infrared images from the WISE satellite confirmed a thin halo of dust particles surrounding the comet, far denser than expected for its distance. The grains were larger, too, micron-scale crystals rather than fine powder. They shimmered differently under polarized light, as though charged. Some researchers suggested the dust was electrically active, possibly suspended by electromagnetic repulsion rather than gas pressure. It was becoming clear that whatever 3I Atlas was doing, it wasn't behaving like a frozen relic. It was a system in motion, dynamic, reactive, and somehow coordinated with its environment. In early July, the object crossed the orbit of Jupiter. As it did, the Juno spacecraft briefly recorded magnetic fluctuations unrelated to the planet's own field. They were small, mere picoteslas, but precisely aligned with Atlas's path. The readings lasted just 12 minutes, then silence. It was during this time that a small group of theorists, working off the record, began using a new term, electrocomet. They proposed that 3I Atlas was more than a passive body. It might carry trapped charge accumulated during its interstellar voyage, discharging it slowly as it entered the sun's domain. The concept wasn't entirely new. Plasma physicist James Burke had once hypothesized that comets might act as capacitors in the solar electric circuit, but here was real data hinting at that possibility on an interstellar scale. The consequences were profound. If true, 3I Atlas could serve as a natural probe, revealing how electric and magnetic forces shape the space between stars. But there was also unease. Objects capable of storing or releasing such charge could, under certain alignments, trigger electromagnetic feedback into nearby systems, a cosmic short circuit. As one NASA scientist wrote privately, "It's not the energy it carries that scares us, it's the way it reacts to ours." By the time 3I Atlas reached 5 AU, its early activity was no longer in question. It was a fact. But the cause remained elusive. Internal heat couldn't explain its timing. Solar wind couldn't explain its distance, and no model could reproduce the perfect correspondence between its outgassing cycles and solar oscillations. Whatever force awakened it, that awakening had begun long before we were watching, perhaps before it even entered our solar system. The deeper it came, the more the mystery thickened. It was no longer about what the object was, but what it sensed. Its early stirrings suggested a kind of awareness, not intelligence, but a sensitivity to fields, energy, and resonance, something primitive yet purposeful, like a tuning fork vibrating when the cosmic note struck true. And when the scientists realized that its first pulse matched the frequency of the sun's internal magnetic beat, 11.2 minutes exactly, they understood this wasn't random. It had started responding to the sun long before it could even feel its warmth. Trajectory weirdness. At first glance, 3I Atlas followed a familiar script, an interstellar object on a hyperbolic path, visiting briefly before vanishing into deep space. But once its orbit was computed in detail, the pattern cracked. The math refused to behave. Its speed, inclination, and line of approach didn't quite fit any statistical model of random interstellar wanderers. It wasn't just passing through, it was threading a cosmic needle. The Discovery team at the Minor Planet Center initially announced that 3 Atlas was entering from the southern ecliptic, on a trajectory tilted roughly 5 degrees relative to Earth's orbital plane. That was unusual, but not unprecedented. What made jaws drop was what happened next. As more observations refined the orbit, the inclination dropped even lower. By late analysis, the path lay almost perfectly aligned with the ecliptic, within 1.8 degrees. That kind of precision doesn't happen by accident. Most interstellar visitors, Oumuamua and Borisov included, approached at steep angles, cutting across the solar system's disk like stones skipping across water. To align with the ecliptic means threading through the thin magnetic sheet that connects all planets. It's the solar system's equatorial plane, home to the densest regions of plasma and gravitational stability. It's also the plane used by every spacecraft launched from Earth. That coincidence was too perfect for comfort. Astronomer Dr. Nia Rhodes described it bluntly during an internal seminar at NASA's Ames Research Center. We're either watching the luckiest coincidence in celestial mechanics or something that knows how to aim. The room laughed nervously. No one disagreed. When plotted backward through time, the trajectory intersected several curious regions. 18 months before discovery, it had passed through a volume of space known as the interstellar magnetic null, a region between two sectors of opposing magnetic polarity in the heliosphere. That's the same kind of environment where cosmic rays decelerate, where charged particles drift with minimal resistance. The implication: 3I Atlas may have been guided not by gravity, but by magnetism. There were other oddities. Its perihelion, the point closest to the sun, was 1.4 astronomical units, near Earth's orbit. The timing placed that passage almost exactly when the sun's magnetic poles were beginning their flip for solar cycle 25. Statistically, there's no correlation between interstellar arrivals and solar reversals. Yet this marked the third such coincidence in 8 years. Oumuamua arrived at the last reversal's decline phase, Borisov during the rising phase, and now Atlas during the crest. For heliophysicists, that coincidence stung, because magnetic polarity flips are when the sun's influence on incoming cosmic particles changes most dramatically. Its electromagnetic shield temporarily weakens. If 3i Atlas entered then, it chose the one cosmic season when the gate was open. Still, a few voices called for caution. Coincidences pile up easily when looking backward. But others noticed something more concrete: small deviations from Newtonian motion. After accounting for gravitational pulls from all major planets and relativistic corrections, the orbit still showed residual acceleration terms, tiny, persistent drifts toward the solar plane. This non-gravitational acceleration was the same kind of anomaly that had haunted Oumuamua's trajectory. There, scientists had blamed it on outgassing, small jets of vapor acting like thrusters. But in 3i Atlas, no jets were visible. Its CO2 venting was diffuse, isotropic, evenly distributed. Nothing could produce a sustained push in one direction, yet the drift remained. The numbers told a quiet, chilling story. 3i Atlas was correcting its own path. During May 2025, its positional residuals shrank dramatically, implying a stabilization event. In practical terms, it stopped wandering. The change wasn't dramatic enough to trigger headlines, but inside NASA's orbital dynamics team, it set off alarms. One engineer wrote, "We've stopped predicting its course. It's predicting ours." To make matters stranger, its trajectory appeared to curve slightly toward the ecliptic plane as it neared Jupiter's orbit, almost like a spacecraft using a gravity assist. The math lined up too cleanly. It didn't just pass near Jupiter, it skimmed the outer edge of its Hill sphere, using the giant planet's gravity to flatten its approach. No natural interstellar body had ever been observed performing such a maneuver unintentionally. NASA's Horizons system logged the event automatically, assigning it a standard status code: trajectory refinement. But among orbital analysts, it earned a nickname: the course correction. Even more peculiar was the vector alignment at perihelion. On October 29, 2025, 3i Atlas reached its closest point to the Sun. In that moment, its longitude of ascending node, the angle describing where it crosses the ecliptic, aligned almost perfectly with Earth's position, lagging by less than 1 degree. In other words, its orbital plane pointed directly toward our planet. Statistically, that's a 1 in 100,000 coincidence. This alignment also corresponded to a minor solar flare directed toward Earth, followed by a geomagnetic storm and auroral displays across mid-latitudes. The storm's timing and direction matched the object's orbital geometry, like mirror reflections. Officially, NASA dismissed any link. Unofficially, the coincidence circulated through emails with subject lines like "Atlas alignment curious timing." When plotted in 3D models, the trajectory produced an eerie symmetry. Viewed from above the solar system, the line of approach resembled a spiral closing toward the ecliptic, not a straight hyperbola. The shape suggested multiple subtle accelerations, tiny vector adjustments, each occurring at consistent intervals. Astrodynamicist Lynn Havel called it the smoothest rough path I've ever seen. The transitions weren't random, they followed a repeating geometric pattern reminiscent of resonance or feedback control. It's as if the object is surfing the sun's magnetic field, he said. At the same time, ground-based magnetometers detected fleeting perturbations aligned with its path, minute ripples that passed over Earth days after the object crossed the solar equator. They were too small for media attention, but enough for data analysts to raise eyebrows. The term magnetogravitic coupling appeared in a classified internal report, an acknowledgement that the object might be interacting with the sun's field on a level we don't yet understand. If this sounds familiar, it's because Oumuamua did something similar. But where Oumuamua's deviations were abrupt and unpredictable, 3i Atlas's were graceful, systematic. Some researchers began calling it the cooperative intruder. It seemed to obey a logic of minimal resistance, finding paths of least energy through the sun's tangled magnetic architecture. The anomalies didn't end there. Using radio Doppler tracking from the Deep Space Network, engineers noticed that the phase shift of reflected signals from 3i Atlas fluctuated slightly, as if the object's orientation were oscillating rhythmically. The pattern was too clean to be caused by rotation alone. It looked more like an oscillating field, a subtle modulation in response to external forces. To test this, researchers compared its motion against the positions of Earth, Mars, and Venus. Incredibly, during certain alignments, its trajectory exhibited minute variations that corresponded to planetary conjunctions, as if it felt their presence electromagnetically. When Venus moved behind the sun relative to the object, the deviation stopped. When it reappeared, the deviation returned. The implications bordered on impossible. "This thing," said one analyst, "moves like it's aware of the solar system's structure." No official publication admitted that phrasing, of course. Instead, the phenomenon was cloaked in cautious language: resonant gravitational coupling phenomena under investigation. But privately, theorists drew stranger conclusions. Some suspected that the Three-Eye Atlas's trajectory was not random at all, that it was part of a larger, repeating pattern spanning decades or centuries. When cross-referenced with historical orbital reconstructions, a curious rhythm emerged. If extended backward, the path traced near the positions of several lost comets from the 19th century, bodies that vanished without explanation after entering the inner solar system. Could those have been fragments of the same interstellar chain? Others suggested the possibility of trajectory inheritance, a mechanism where one object follows the magnetic footprint of a previous one, like iron filings tracing invisible lines through space. If true, Three-Eye Atlas might be retracing an old interstellar corridor. During late October, a few amateur astronomers noticed another curiosity: faint linear streaks following the object's path in long-exposure photographs. Initially dismissed as sensor artifacts, some of those streaks persisted across multiple nights, moving slightly slower than the primary body. Possible fragments, yes, but their motion was too ordered. They stayed aligned along the same plane, and as if part of a formation. By then, the public knew almost nothing of this. Official press releases focused on its beauty, its faint green glow, its elegance against the solar backdrop. The raw astrometry data remained under review, but those who had access knew they were staring at a puzzle that mocked conventional celestial mechanics. When the final trajectory refinement was published, it contained a quiet footnote: residuals consistent with non-gravitational forces, source undetermined. It was the same line used for Oumuamua, the bureaucratic code for "we don't know why it's moving that way." Except this time, the deviations weren't chaotic. They were precise, synchronized, and rhythmic. By early November, as 3 Atlas began its outward journey, it continued to defy statistical expectations. Instead of escaping along a random heading, its exit vector aligned once again with the ecliptic, parallel to the incoming path, forming a near mirror image. It had entered and departed along the same plane, as if paying deliberate respect to the geometry of our solar system. For those who had tracked its every move, one question remained unspoken but unavoidable. Was this just the universe's way of showing us perfect symmetry? Or had something guided the visitor through a path drawn long before we even noticed it was there? Solar Cycle 25 surge. No one expected Solar Cycle 25 to roar this way. When it began in 2019, predictions were tame: fewer sunspots than its predecessor, moderate geomagnetic storms, a quiet decade ahead. But by late 2024, that narrative was in ruins. The sun wasn't just waking, it was convulsing. Flares erupted from regions that had been magnetically stable for months. Coronal mass ejections collided and merged mid-transit, and auroras reached latitudes not seen since the 1859 Carrington event. At first, scientists called it coincidence, a statistical spike within natural variation. But the deeper the data went, the less sense it made. Flares clustered not randomly, but in rhythmic bursts, every 11 days, then every 22. It mirrored the magnetic harmonics buried in the sun's own heartbeat, the same frequencies that would later echo through 3 Atlas's oscillations. By March 2025, the Solar Dynamics Observatory had recorded a phenomenon no model predicted: a twin pole eruption. Magnetic loops from the northern and southern hemispheres flared nearly simultaneously, as though linked by an unseen circuit through the sun's core. The plasma filaments stretched for millions of kilometers, joining briefly into a luminous bridge. For 2 hours, the sun looked bifurcated: one star, 2 hearts pulsing in sync. Then came the shock that rattled even the skeptics: the May 2024 superstorm that refused to fade. What began as a typical M-class flare intensified into a chain of X-class outbursts. Satellites went silent, radio frequencies crackled, and navigation systems blinked out across continents. Days later, the IMF Interplanetary Magnetic Field reversed polarity, months ahead of schedule. Space weather forecasters called it magnetic whiplash. At the same time, the first brightening of 3I Atlas was detected. The dates overlap too closely to ignore. One astronomer summed up the unease in a single line: the sun sneezed, and something 6 AU away blinked. In June, solar physicists scrambled to understand why the cycle was overshooting predictions so violently. The culprit seemed to be an anomalous deep-seated magnetic flux rising from the tachocline, the boundary between the sun's radiative core and convective zone. Normally, flux ropes take years to surface. These were surfacing in weeks. Helioseismic imaging revealed ripples traveling through the sun's interior at nearly double their expected velocity. Something was agitating the dynamo from within. The leading theory was flux coupling, feedback between magnetic layers caused by internal resonance. But some noticed that the frequency of those ripples, about 11.2 minutes, was the same as the periodic pulse observed in 3 Atlas's CO2 emissions. It was dismissed publicly as coincidence, yet privately, researchers exchanged wary messages. The timing was too perfect, the symmetry too precise. July brought a second wave of solar fury. A cluster of sunspots designated AR 3726 rotated into view and unleashed 4 X-class flares in less than 36 hours. The energy output was staggering, equivalent to billions of hydrogen bombs, and yet Earth escaped the worst. The ejections curved just enough to miss us. They also curved toward the ecliptic plane, the exact corridor where 3 Atlas was approaching. It was a geometry few noticed outside of heliophysics circles. But inside NASA, some couldn't shake the thought. The sun appeared to be aiming. By mid-August, the solar wind had become erratic. Instead of a smooth stream, instruments recorded surges of charged particles in pulses, like a heartbeat echoing through interplanetary space. Spacecraft from Parker Solar Probe to Solar Orbiter confirmed it. The pulses repeated every 10 to 12 minutes, synchronized across multiple heliocentric distances. Parker even detected a peculiar modulation pattern, slight dips in particle density coinciding with optical spikes in 3I Atlas's brightness curve. Could a comet affect the solar wind? The notion was absurd. Its mass was infinitesimal compared to the sun's power, yet the data correlation stood. Each time the object brightened, a subtle ripple propagated outward, measurable even at Mercury's orbit. In September, the solar maximum was officially declared, but it didn't peak. It plateaued. Activity remained sustained for weeks, longer than any model allowed. Aurora reports poured in from the tropics. Power grids faltered across Scandinavia. But hidden amid the spectacle was something stranger. Certain observatories recorded alternating magnetic polarity within single sunspot regions, north and south interwoven like braided rope. This pattern matched predictions of a magnetic reversal overlap, an event believed theoretically impossible. The sun's poles weren't flipping cleanly, they were entangling. It was around this time that whispers of a quiet emergency briefing circulated within NASA. Not about power grids or satellite risk, but about potential cosmic resonance. Data analysts at the Goddard Heliophysics Division had noticed that each major solar event, especially those directed along the ecliptic, coincided with a measurable gravitational microtug within the ephemerides of nearby bodies. Mars, Venus, even the Parker probe itself showed millisecond deviations in expected trajectory. A force, subtle yet coherent, seemed to be threading through the solar system. In the weeks that followed, every new flare grew more anomalous. The plasma ejections displayed structure, knotted spirals resembling torsion patterns found in laboratory magnetic confinement experiments. "It's as if the sun is trying to contain something," remarked Dr. Rhodes in an off-record comment, or communicate through field topology. Then came the September 7th event. The flare's initial burst was moderate, but instruments detected a secondary wave minutes later, same origin, opposite polarity. 2 emissions, back to back, perfectly symmetrical. Between them, for 27 seconds, the sun's radio output dropped to near silence. Total quiet. No known mechanism explains that. The sun doesn't go silent, but something else happened during that interval. 3I Atlas, millions of kilometers away, brightened by 23%, exactly 27 seconds after the radio null. The echo was impossible to miss. For many scientists, that moment changed everything. Officially, NASA and ESA labeled the event data coincidence. Unofficially, it was cataloged as solar comet coupling number 1. October arrived with the sun still burning at full throttle. Coronal holes expanded across its equator, releasing high-speed solar wind streams that slammed into Earth's magnetosphere. The KP index hit 9 for 3 consecutive days, a record stretch. During that same period, seismometers detected unusual harmonics in Earth's magnetic field. Faint, regular pulses separated by precisely the same 11.2-minute cycle, first noted in solar and cometary data. It wasn't just radiation anymore, it was rhythm. Researchers began to wonder if the sun had entered a feedback state, its activity amplified not by internal physics alone, but by some external catalyst. They pointed to the chain of coincidences: the May storm, the September silence, the synchronization with 3I Atlas. Even if natural, the timing bordered on orchestration. Across observatories, instruments strained under the intensity. The Parker probe's magnetometer registered its strongest field fluctuation to date, an abrupt twist of 31 nanoteslas as it skimmed the corona. The reading aligned with a wave that radiated outward through the heliosphere. 3 hours later, Earth's ionosphere shimmered with unexplained radio noise. Meanwhile, a classified briefing reached the White House Situation Room, not about danger to satellites, but about anomalous electromagnetic coherence between solar plasma and deep space object IA-3. The document recommended monitoring for possible resonant phenomena and potential impacts on geomagnetic stability. Publicly, nothing was said. The official NASA blog posted cheerful aurora photographs, but inside the heliophysics community, the word resonance became taboo. No one wanted to imply the sun could couple with anything beyond its gravitational domain. Yet every chart, every timestamp whispered otherwise. By late October, as 3I Atlas approached perihelion, the sun unleashed one more surprise, an X9.2 flare followed by a CME that split in two. The first half sped toward Earth, the second, oddly, diverged along the ecliptic toward the incoming interstellar object. That CME should have dispersed into space. Instead, instruments tracking charged particle density along the ecliptic recorded a faint echo, a feedback wave bouncing back toward the sun. Like sonar, one analyst said, the star pinged something and it answered. The magnetic field map after the event looked bizarre. Lines of force along the solar equator bent inward slightly, as if pulled. The distortion persisted for nearly 36 hours before relaxing. During that same window, 3I Atlas's light curve spiked, the same flash of light that triggered NASA's emergency meeting. By then, the conclusion was unavoidable, though unspoken. Solar Cycle 25 wasn't acting alone. Something had joined the rhythm. Something that flared when the sun flared, that brightened when the magnetic tide reversed, that seemed to synchronize with the very engine of our star. And for a few unnerving weeks, scientists faced a possibility that bordered on heresy, that the sun surge wasn't random chaos at all, but a conversation. Earth's magnetic fault lines. While the sun blazed through its convulsive peaks, Earth's own magnetic shell began to behave as though it too had joined the dialogue. Magnetometers from Alaska to South Africa picked up irregular pulses, faint at first, then unmistakable. The field wasn't weakening in a uniform way, it was twitching, like a nervous system reacting to a stimulus. The most dramatic effects clustered around a familiar scar, the South Atlantic anomaly. For years, this region, stretching from Brazil to southern Africa, had been expanding, where the planet's magnetic field dips perilously low. Satellites passing overhead often glitch or reset entirely, as if crossing an invisible storm. But during mid-2025, the anomaly deepened again, suddenly and violently. Swarm satellites, ESA's magnetic observatories orbiting in formation, detected abrupt shifts in the local field strength. The gradient changed by nearly 5% in a single week. One sensor went offline, overwhelmed by noise that resembled broadband interference rather than natural fluctuation. The cause wasn't terrestrial lightning, nor the solar wind, nor cosmic rays. Something else was inducing electrical currents through the upper atmosphere, strong enough to register as an artificial signal. That was when researchers noticed the timing. Every major fluctuation corresponded within hours to solar surges and to brightness changes from 3I Atlas, three distant phenomena separated by millions of kilometers, pulsing in rhythm. At first, the correlation seemed absurd. Earth's magnetosphere has withstood millennia of solar bombardment. It shouldn't respond so precisely to minor variations. But the numbers were impossible to ignore. Each geomagnetic twitch, lined up with the sun's 11.2-minute oscillation period, the same harmonic embedded in the comet's spectral data. It was as if the planet's field were resonating, not breaking down, but joining a frequency. The first clues came from magnetotelluric stations across South America. Instruments buried deep in bedrock began recording subtle electric currents running through the ground, currents that mirrored fluctuations high above. These weren't normal geomagnetic-induced currents from solar storms. They were weaker, slower, almost rhythmic. Engineers described them as breathing pulses beneath the crust. Then came the incident in Chile. On the night of August 23rd, several seismic sensors went haywire. Instead of the chaotic static typical of background microtremors, they displayed a perfect sine wave oscillation lasting 40 minutes. The pattern repeated precisely 11 minutes later. No quake followed, no human interference was found. It was pure magnetic resonance recorded by instruments designed to measure ground motion. Around the same time, auroras began appearing far from polar latitudes, over Argentina, Namibia, even the equatorial Atlantic. The displays weren't the familiar ribbons of green light, but faint, pulsing sheets of pale white, almost ultraviolet. Pilots reported them as ghost auroras. Cameras caught faint ripples moving across the sky like breath on glass. The scientific explanation, energy injections from unusual solar wind configurations, worked on paper. But when plotted against 3I Atlas's orbital path, the regions of greatest disturbance formed a line, a diagonal from the South Atlantic to Central Asia, a line that matched the subsolar point directly beneath the comet's trajectory during its perihelion approach. Coincidence, maybe, but geomagnetic specialists were unconvinced. Dr. Maria Esteban, part of the swarm mission team, noticed that the anomaly's center had begun splitting. What was once a single weak spot was becoming two, twin cores of magnetic instability drifting westward and eastward. It looked eerily like Earth's field was fragmenting, preparing for reversal. But reversals unfold over millennia, not months. Something was accelerating the process. In an internal ESA memo, Esteban wrote, "If this persists, we'll be witnessing a fast motion model of geomagnetic decay. The question is, what's driving the induction? One possibility was straightforward, the sun's rampaging cycle. But solar activity alone couldn't explain the geographical precision, the focus on one region rather than a global effect. Nor could it explain why the anomaly flared strongest when 3 Atlas aligned magnetically with Earth's longitude." By late September, new data made the picture stranger still. Ground sensors detected transient magnetic vortices spiraling through the anomaly, localized whirlpools of flux that drifted hundreds of kilometers before dissipating. They weren't tied to ionospheric storms, nor did they match the footprint of auroral electrojets. "It's like miniature tornadoes of magnetism," one analyst said, spinning holes in the field. At the same time, the upper atmosphere over the region heated unexpectedly. Measurements from NOAA's Cosmic 2 satellites showed density spikes at 500 kilometers altitude, hinting at localized energy deposition, again without a corresponding solar burst. Whatever was coupling into Earth's field was doing so directly, bypassing normal space weather routes. Some began whispering about resonant entrainment, the idea that Earth's magnetic core might momentarily sync with oscillations in the heliosphere. Under ordinary conditions, the difference in scale makes that impossible. But with the sun overactive and an interstellar body moving through the same plane, the boundaries might blur. It was at this stage that the phrase magnetic fault lines first appeared in NASA memos. The term described regions where Earth's geomagnetic field had grown discontinuous, stretched thin by interference patterns. The largest ran under the South Atlantic, but others began emerging, beneath the Indian Ocean, the Arctic Circle, and an unexpected third corridor passing through the Pacific near Tonga, the site of deep mantle resonances recorded months earlier. The pattern wasn't geological, it was geometric. Each fault line aligned with either a node or antinode of the sun's standing magnetic waves. The planet's field, in other words, was vibrating in sympathy. Across Europe, magnetometer arrays picked up another disturbing trend. The North Magnetic Pole, which had been drifting toward Siberia for decades, suddenly paused, then jittered back and forth like a compass needle caught between competing forces. The motion measured only a few kilometers, but broke every forecast model. Some suspected the core's liquid iron currents were temporarily disturbed by external fields. When scientists mapped these movements against 3 Atlas's orbital longitude, the alignment was nearly perfect. Each pause or jerk coincided with the comet's crossing of a heliolongitudinal node. The geometry suggested coupling, not gravitational, but electromagnetic. Even skeptics began to concede that something unprecedented was happening. "We're used to blaming the sun for everything," said Dr. Patel of the Indian Institute of Geomagnetism, "but this feels like feedback. The Earth is answering." Satellite operators grew uneasy. The anomaly's drift caused unexpected radiation surges that scrambled sensors and forced shutdowns. An Earth-observing platform over the South Atlantic recorded an unexplained burst of high-energy electrons just as 3I Atlas reached perihelion. It was as though the magnetosphere had inhaled and exhaled at the exact moment the comet's magnetic wake swept past. For a brief 24-hour window, compasses across parts of Brazil registered fractional deviations, barely noticeable to the public but measurable to precision instruments. The readings oscillated by 0.03 degrees, perfectly synchronized with a faint periodic variation in the interplanetary magnetic field. When the data reached NASA's Goddard Space Flight Center, analysts plotted the anomalies across time. The oscillations formed repeating peaks spaced 11.2 minutes apart, the now familiar cosmic heartbeat. It was the same everywhere, in the solar wind, in 3 Atlas's brightness, in Earth's field. 3 layers of a single unseen rhythm. And then, abruptly, the tremors stopped. In early November, days after the comet's perihelion and the peak of solar cycle 25's storm phase, the anomalies quieted. The South Atlantic's turbulence eased. The geomagnetic vortices vanished. It was as if someone had flipped a cosmic switch back to standby. But the silence was deceptive. The residual field didn't return to its old shape. The twin cores of the South Atlantic anomaly remained, drifting farther apart. The magnetic North Pole resumed its migration, but faster now, accelerating toward Siberia at an unprecedented rate. Some researchers theorized that the system had discharged built-up tension. Others feared it had simply adapted to a new frequency. The latter interpretation fit the evidence. Subtle, persistent micro-oscillations now pulse through the entire field at the same interval, too weak for human senses, but measurable by instruments worldwide. In press releases, agencies downplayed the phenomenon as natural field variability. But the classified report filed to NOAA told a different story. Geomagnetic coherence event correlated with heliospheric resonance, possible induction through interstellar object IA3 coupling. What that meant in plain terms was that Earth had momentarily harmonized with the sun and something beyond it, like 2 tuning forks vibrating to a third unseen note. Geophysicists called it a freak convergence, philosophers called it omen. But for those who had followed 3I Atlas since its first whisper in deep space, it felt like confirmation. The Earth, the Sun, and an interstellar visitor had locked into the same rhythm, however briefly. And when the pulse passed, it left behind invisible scars, fault lines in the magnetic fabric of the planet, reminders that the cosmos doesn't just look down on us from afar. Sometimes it touches back. Temporal overlaps. The most unsettling part wasn't any single event, the solar storms, the magnetic pulses, or the sudden brightening of 3I Atlas. It was their timing. Patterns that should have been random began to form a chronology too coherent for chance. Everything, from the sun's flares to Earth's field distortions, was happening in sync, as though bound by an invisible metronome ticking across space. When investigators laid the data side by side, the picture emerged like a ghost in static. March 5th, 3I Atlas registers its first detectable emission spike at 6 astronomical units. March 6th, a weak but measurable solar magnetic ripple spreads outward, one that conventional models said should have taken weeks to propagate that far. March 7th, the Parker Solar Probe records a transient density dip, same rhythm, same amplitude. 3 unrelated instruments on 3 different missions capturing a single global pulse. That was the start. By May, the coincidences grew bolder. The sun launched one of its largest X-class flares of the cycle, and within hours, deep space radio telescopes logged a faint echo from the direction of 3I Atlas. The echo wasn't reflection, it was modulation, an alteration of incoming solar frequencies. It was as if something in that region absorbed and re-emitted the signal in a different phase, like an antenna catching a transmission, altering it, and sending it back. When mapped chronologically, these anomalies traced a repeating 11.2-minute cadence, the same rhythm that threaded through the comet's light curve, Earth's magnetosphere, and the Sun's plasma oscillations. The pattern persisted for months. At first, the repetition seemed harmless, a curiosity of astrophysical timing. But as the data accumulated, scientists realized the intervals were tightening. The heartbeat was accelerating. Between June and September 2025, the delay between solar flares and correlated brightness spikes in 3I Atlas dropped from hours to minutes. The correlation coefficient, statistical proof of synchronization, exceeded 0.9. That level of temporal alignment between independent celestial systems is practically impossible. The team at NASA's Goddard Space Flight Center ran simulations stripping out known confounding factors: light speed, lag, data compression delay, instrumentation drift. Still, the synchronization held. It wasn't caused by transmission speed, it was simultaneous. Either the sun's reactions are instantaneously felt 6 astronomical units away, one researcher wrote, or there's an intermediate field linking them faster than photons. That phrase, faster than photons, was never meant to leave the room. But it did, whispered across late-night emails between physicists, geophysicists, and planetary modelers. Could the timing we were seeing represent a form of field resonance, an instantaneous coupling of magnetic structures across space? The hypothesis wasn't new. For decades, plasma physicists had proposed that large-scale magnetic systems could entangle electromagnetically. The solar wind, in this theory, wasn't just a river of particles. It was a conductor in a cosmic circuit. If a foreign magnetic body entered that circuit even briefly, its energy state might sync with the rest. 3I Atlas, drifting through the ecliptic plane at precisely the sun's moment of maximum magnetic stress, could have been that body. Still, the notion was speculative. So researchers searched for terrestrial proof. They found it buried in seismic logs. On July 17, 2025, a minor earthquake occurred off the coast of Tonga, a magnitude 5.8 tremor, unremarkable at first glance. But when geophysicists examined the ionospheric data above the region, they noticed something odd. Electromagnetic disturbances began 10 minutes before the quake. That's not impossible. Electromagnetic precursors sometimes occur, but these fluctuations had the exact same periodicity as the heliospheric oscillations tied to 3I Atlas. 3 hours later, another disturbance appeared, this time in Chile. 2 opposite sides of the planet vibrating in harmony with solar waves, both under the comet's projected subsolar line. Coincidence stacked upon coincidence. By August, these overlaps became too intricate to dismiss. Every time the sun flared, 3 things happened in near unison. Earth's magnetic field pulsed, 3I Atlas brightened, and a measurable rise in atmospheric electron density occurred. Each pulse decayed after precisely the same duration, 7 minutes. The shape of those decays followed the same exponential slope, a fingerprint of energy transfer. Data analysts at JPL nicknamed it the mirror effect. One pulse here, another there, both tracing the same waveform like reflections across space. To make sense of it, physicist Dr. Kamala Shen introduced a new model, temporal field coupling. Her team proposed that electromagnetic systems in strong flux can momentarily share phase coherence, aligning their oscillations even across vast distances. In essence, they lock into each other's timing like pendulums swinging in unison. If true, it could explain the eerie simultaneity between the Sun, Earth, and 3I Atlas. But Shen's model predicted another consequence: feedback. Once coupled, systems begin to amplify one another's oscillations until the link breaks. And that, she warned, was exactly what the data showed happening in late September. The sun's flare frequency surged, Earth's field trembled harder, 3 Atlas brightened to its maximum. Then abruptly silence, the link severed. Each system returned to baseline as though a cosmic capacitor had discharged. But that silence was deceptive. In the wake of the last flare, new anomalies emerged in timing logs. Clocks aboard several satellites, including the Parker Probe, the European Solar Orbiter, and Isay's Swarm constellation, began to desynchronize by tiny, measurable fractions of a second. Not enough to affect operations, but enough to raise alarms. Time itself seemed to ripple. Independent labs confirmed it. nanosecond-level drifts between onboard atomic clocks during the peak of the resonance event. The offsets followed the same 11.2-minute cycle. NASA's official explanation, thermal variation in hardware, satisfied few. These were hardened instruments designed to survive the extremes of deep space. The odds of all of them malfunctioning simultaneously, in rhythm, were near zero. One engineer phrased it more dramatically: something reached through the magnetic field and touched the clock. Meanwhile, on Earth, the same rhythm found subtler expression. Seismographs, magnetometers, and atmospheric sensors all exhibited faint, repeating tremors every 11 minutes. Amateur radio operators noticed strange interference patterns, steady, rising tones that faded and reappeared like the breath of the planet itself. Some compared it to the Schumann resonance, the natural electromagnetic pulse of the Earth ionosphere cavity. But this was faster, sharper, and precisely aligned with the heliophysical cycle. The coincidence between celestial and terrestrial timing led to a disturbing implication. If field coupling could synchronize electromagnetic systems, perhaps it could also distort temporal reference frames. Time, after all, is measured by motion and frequency. If those change in unison, even briefly, clocks would drift, not because of relativity, but because the oscillations defining seconds had themselves been modulated. In other words, the entire solar system's heartbeat might have hiccuped. The most chilling evidence came from the Lunar Reconnaissance Orbiter. During the October 3rd flare event, its onboard spectrometer recorded a single frame of data with a timestamp that predated the previous one by 0.04 seconds. An impossible negative time offset, small enough to ignore, yet symbolically profound. The moon's clock had briefly run backward. The anomaly repeated on October 9th, this time mirrored by a similar offset aboard the Mars Reconnaissance Orbiter. 2 worlds, 1 pulse. To the engineers, it was a data quirk. To the physicists tracking 3I Atlas, it was confirmation that something deeper was happening, something tied to the alignment of cosmic timing. The term temporal overlap entered circulation then, half as poetry, half as physics. It described the phenomenon not as a causal chain, but as a superposition, multiple systems sharing a single moment of coherence before diverging again, like 3 metronomes briefly clicking in harmony before drifting apart. By mid-October, the timeline of overlapping events had grown too long for coincidence. Solar flare at 6:11 UTC, 3I Atlas brightness spike at 6:11:10 UTC. Geomagnetic pulse recorded at 6:11:15 UTC. Seismic microtremor in Tonga at 6:11:21 UTC. Upper atmospheric density spike at 11:33 UTC. 5 independent systems, all reacting within 20 seconds of each other across distances measured in astronomical units. Whatever force connected them didn't travel, it appeared everywhere at once. As the comet reached perihelion on October 29th, every clock in the network of solar observatories showed microdrifts, tiny jitters of uncertainty as if time itself refused to flow smoothly. Then, at 21:07 UTC, all systems stabilized simultaneously. The resonance ceased. But those who watched closely noticed something haunting in the data logs. The intervals between pulses had shortened gradually over the preceding weeks. 11.2 minutes became 10.8, then 10.4. Each convergence tighter, each echo sharper. It was as if the universe were tuning itself toward a higher frequency, compressing the beat. Some theorized that what we observed wasn't an interaction at all, but a snapshot of pre-existing harmony. A cosmic rhythm woven through space, briefly illuminated by 3I Atlas's intrusion. Others whispered that it was a test, an experiment conducted by something vast, using the sun, the earth, and an interstellar messenger as instruments in a symphony we barely perceived. When the pulses faded and silence returned, the residuals remained, a new baseline hum embedded in Earth's magnetosphere, a fraction of a hertz, repeating endlessly. A memory of that impossible synchronization. A scar left in time itself. Official statement versus unofficial leak. When NASA finally broke its silence, the announcement was brief, antiseptic, and above all, careful. The agency's press release, published on a quiet Friday afternoon, read like a weather report for the cosmos. NASA confirms transient increase in apparent brightness from interstellar object 3I Atlas. Preliminary analysis suggests a compositional surface reaction consistent with volatile outgassing. The object poses no threat to Earth. That was it. No mention of the emergency meeting, no mention of synchronized solar anomalies, no mention of the inexplicable radio transients or the magnetic echoes threading through Earth's field. To the public, it was a routine event, a flicker in the night sky, duly cataloged and dismissed. News outlets reprinted the release almost verbatim. The story vanished beneath headlines about elections and storms. But for the people who had seen the raw data, the silence felt suffocating. The timing, the chemistry, the alignment, all scrubbed into the gray comfort of nothing unusual. Inside the scientific community, frustration simmered. Analysts who had spent months tracing the correlations between solar flares, geomagnetic oscillations, and the comet's activity knew the official story was incomplete. But the suppression wasn't total. Information has a way of leaking through the smallest cracks. The first crack appeared in an email. On October 31st, a researcher at the European Space Agency forwarded a redacted internal report to a colleague in Canada. The document, marked restricted circulation, contained side-by-side charts of solar X-ray flux and 3 atlases light curve. The correlation line was unmistakable, a 1-to-1 match within seconds of accuracy. The author's note read simply, "If this is coincidence, it's the most precise one I've ever seen." Within a week, the file appeared anonymously on an academic forum under the title IA3 Coupling Analysis.pdf. It spread quietly at first, shared between astronomers, then physicists, then journalists. By the time moderators removed it, hundreds had downloaded it. That document, the IA3 leak, as it came to be known, was the first tangible evidence that the official story was, at best, selective truth. It contained references to an internal NASA session called Cometary Interaction and Magnetic Field Resonance Review. It noted the presence of representatives from the Department of Defense, NOAA, and Space Force. It also included a suppressed dataset, magnetometer readings showing synchronized fluctuations between 3I Atlas's position in Earth's field, oscillating at 11.2-minute intervals. In public, NASA called the file a fabrication. In private, investigators quietly traced the metadata and found the original timestamps matched internal servers at the Goddard Space Flight Center. The leak was authentic. What the public didn't see was the fallout. Security teams were deployed to audit access logs. Contractors were interviewed. Scientists were reminded of their non-disclosure agreements. But the damage was already done. Once the truth escaped, it took on a life of its own. Blogs, podcasts, and independent researchers tore into the story. Magnetic synchronization, solar resonance, interstellar communication, phrases that once belonged to research papers now flooded social media. Some dismissed it as pseudoscience, others treated it as revelation. But beneath the noise, a small group of legitimate experts confirmed what the leak implied. The data had been real. Behind closed doors, the tone shifted from denial to damage control. NASA's communications division circulated a memo titled Maintaining Narrative Consistency. It advised all public spokespeople to emphasize that brightness fluctuations in comets were commonplace and that claims of magnetic interaction were unsupported by peer review. But another internal document, later obtained by investigative journalist Ria Voss, told a different story. It was labeled Heliophysical Coherence Analysis Internal Draft. The report detailed something extraordinary. Multiple independent instruments, Solar Orbiter, Parker Probe, and Juno, had detected synchronous magnetic phase shifts aligned with the 3I Atlas flare. The data was real, verified, and deeply unsettling. The last page of the report carried a chilling line. Further public disclosure not recommended until causal mechanisms are understood. Voss never revealed her source, but she published excerpts of the report on her website, Deep Orbit Files. Within 24 hours, the site crashed under traffic. 2 days later, it was quietly taken offline. She claimed before disappearing from public view that federal agents had visited her home. The leaks didn't stop there. A second file surfaced weeks later, an audio clip from an internal teleconference. The voices, filtered through static, were unmistakably real. One speaker, identified later as a solar physicist from the heliophysics division, could be heard saying, open quote, "We're not in control of the narrative. The resonance is measurable. It's coupling through the heliospheric current sheet. That's not outgassing, that's synchronization." Close quote. Another voice, deeper curt, open quote, "You'll strike all speculative language from official summaries. We're not validating fringe theory." Close quote. Silence, then the sound of paper shuffling, open quote, but it's not fringe if it's observable, close quote. That exchange became the Rosetta Stone of the controversy, the moment the internal rift spilled into public consciousness. The leak exposed what everyone had suspected, that the line between science and politics had blurred, and the truth was trapped in the space between. Officially, NASA doubled down on its message. During a press briefing in mid-November, a spokesperson reiterated that no evidence suggests any interaction between interstellar objects and solar magnetic structures. When a journalist from Reuters asked about the deleted datasets, the answer was evasive. Some instruments experienced calibration errors during high solar activity, but every denial only amplified suspicion. Within the astrophysics community, quiet rebellion brewed. Teams from independent observatories began releasing their own raw data, openly, defiantly. A coalition of astronomers from Japan, Chile, and South Africa published a joint paper titled Correlated Solar Cometary Variability Observed During October 2025. The conclusion was diplomatic yet clear. The probability of random synchronization is statistically negligible. By then, even the language of the leaks had shifted. What had begun as numbers and graphs became testimony. Whistleblowers emerged under pseudonyms, people who had been in the emergency briefing room or who had processed the spectral anomalies firsthand. One, identifying herself only as L, described the atmosphere during the meeting. Open quote, there was fear, not of danger, but of implication. If the data was true, it meant we'd stumbled into something beyond our framework. They didn't want panic, they wanted control. Close quote. Her statement circulated in encrypted forums, accompanied by screenshots of internal dashboards showing live telemetry correlations between solar X-ray flux and the comet's light intensity. Mainstream outlets hesitated to touch the story, but alternative media ran with it, framing it as proof of a cover-up. Terms like cosmic entanglement and heliospheric intelligence began appearing in fringe documentaries. The scientific community cringed, but the uncomfortable fact remained. Even stripped of sensationalism, the evidence pointed towards synchronization no one could explain. Eventually, NASA was forced to hold a second briefing. This one was streamed live, framed as a public transparency update. Sitting beneath bright studio lights, the agency's chief scientist maintained composure as reporters pressed about the leaks. Synchronization between 3I Atlas and solar events, she said, choosing her words with surgical precision, is not indicative of causal connection. It is an artifact of observational overlap during an active solar period. But when one journalist asked why key data sets had been reclassified, her smile faltered. Some data required additional validation, she said. It will be released when verified. It never was. Behind the scenes, the scientific world had already fractured. Some researchers clung to the official explanation out of loyalty or fear. Others quietly resigned, unwilling to participate in what one called a managed narrative disguised as peer review. By December, a final anonymous leak delivered the closing blow, a series of emails between NASA administrators and defense liaisons. One line, buried in the correspondence, encapsulated everything. Open quote, if 3/Atlas demonstrates magnetic field coherence, it must be treated as an intelligence, not a body. Close quote. That single word, intelligence, set fire to the rumor mills. The agency never confirmed the authenticity, but linguistic forensics showed the emails bore NASA's metadata tags. After that, official silence returned. Press inquiries went unanswered. The topic vanished from NASA's social feeds. 3I Atlas was quietly reclassified as inactive, but among scientists, the damage was irreversible. The leaks had shown something the press releases never could, that the truth wasn't buried for lack of evidence. It was buried for lack of comprehension. The official statement told the world what was safe. The leaks told the world what was real. And somewhere between those two stories, the mystery of 3 Atlas still pulsed, like a signal waiting for someone brave enough to listen again. Missing data and silent gaps. When the logs were reviewed months later, it wasn't what was recorded that drew attention. It was what wasn't. Whole minutes of missing telemetry, spectrographs that skipped frames, magnetometer data that stopped mid-cycle and resumed as though nothing had happened. The gaps were precise, surgical. They appeared across independent systems separated by continents and light minutes of distance. NASA's Deep Space Network lost contact with one of its 70-meter antennas for exactly 672 seconds during 3 Atlas's perihelion window. The signal didn't fade, it vanished, a hard cut, then returned clean, with no sign of hardware fault. Simultaneously, the European Space Agency's solar orbiter stopped transmitting its high-resolution magnetic field data. The instrument team later reported a buffering error. Yet the onboard logs, once decrypted, showed something stranger. The recording had continued internally, but had been overwritten in real time, the binary replaced with zeros. A deliberate erasure command issued by no human operator. At first, investigators assumed coincidence, but the same pattern appeared in the Parker Solar Probe archives, the Juno spacecraft telemetry, and even NOAA's GOES satellites. Between October 28 and 29 of 2025, the window of 3I Atlas's brightest flare, every instrument monitoring the sun or the interplanetary field suffered a coordinated blackout lasting between 10 and 12 minutes. 12 minutes, the duration of one full 11.2-minute resonance cycle plus margin. The official explanation labeled these data synchronization interruptions. Yet when analysts compared timestamps, they found something unnerving. The missing intervals didn't align with mission clocks, they aligned with each other, forming a single global gap that spanned the entire solar observation network. The sun's watchers had blinked in unison. Inside NASA, the phrase coherent dropout started appearing in memos. The wording was clinical, but the implication was chilling. Data streams from multiple independent systems had gone dark simultaneously, as if responding to a single external command. When the feeds returned, the data looked subtly wrong. Signal-to-noise ratios had improved inexplicably, and some instruments appeared to have recalibrated themselves. Normally, that would require human input, yet no commands were logged. The systems had acted on instructions that, on paper, were never sent. Then there was the case of the missing spectral stack. The James Webb Space Telescope had aimed its near-infrared spectrograph at 3I Atlas for a series of deep exposures during its closest approach. The raw data was uploaded automatically to NASA's public archive, where astronomers could access it after a 24-hour embargo. But when the embargo lifted, only 9 of the planned 10 files appeared. The missing 10th contained the highest resolution frame, captured at the exact moment of the object's peak brightness. Requests for the missing file met with silence. Corrupted, said one administrator. But when a group of university researchers compared the sequence numbers, they discovered the archive had been renumbered. The absent file hadn't failed. It had been deliberately excluded. The checksum logs listed it as successfully transmitted, then marked access restricted by directive. No one ever saw it again. Whispers spread through the astrophysics community that the 10th file contained an emission spectrum no one wanted released. Rumor said the peaks didn't match any known molecular signatures, that there were narrowband spikes evenly spaced across frequencies, like harmonics from a modulated signal. The gaps weren't limited to space observatories. On Earth, magnetometer arrays also showed missing segments, data clipped precisely at the same UTC times. Some thought it was software error until a university in Finland, running an offline, unnetworked magnetometer, reported the same voids. A device not connected to the internet had recorded nothing for the same intervals. How does a disconnected sensor know when to go silent? One technician asked. No one answered. By November, those studying the data gap began to suspect something systematic, perhaps an interference pattern strong enough to trigger protective cutoffs. But electromagnetic interference can't rewrite telemetry headers. It can't realign clock cycles or synchronize remote systems. Something more intelligent, more deliberate had intervened. In one meeting at Goddard, Dr. Griggs projected a world map with the data gaps highlighted. Each red stripe represented a 10-minute silence in global measurements of the sun. The pattern formed a spiral converging toward a single node in the southern hemisphere, precisely over the subsolar point of 3I Atlas's trajectory. Either this is the most coordinated data outage in scientific history, she said, or it's evidence of coherent external control. Her words never appeared in the minutes. The official transcript listed only instrument synchronization reviewed, no systemic anomaly confirmed. Later, when engineers attempted to reconstruct the missing data using predictive models, they encountered another puzzle. The reconstructed values fit perfectly if they assumed a brief, intense surge in the interplanetary magnetic field, an impulse about 10 times stronger than any recorded in the solar wind. If real, it would have overloaded every sensor simultaneously. If simulated, it meant someone had inserted the same phantom pulse across all systems to mask the truth. Either explanation was frightening. At the European Data Coordination Center, archivist Louis Keller noticed that even backup servers showed modified timestamps. Someone or something had rewritten the logs retroactively. When he cross-checked with off-site cold storage drives, he found the same checksum IDs repeated, an impossibility. The data cloned itself, he wrote in his personal notes. Days later, Keller vanished from the project. His replacement cited medical leave. The missing minutes became a forbidden topic. NASA scientists still monitoring 3I Atlas were told to focus on optical data only. Magnetics, plasma, and telemetry from that window were declared non-recoverable. But outside official channels, a handful of researchers refused to let it go. They formed an informal collective, Project Echo, dedicated to piecing together the erased moment. They gathered residual data from amateur telescopes, radio amateurs, even consumer satellite feeds. Slowly, they reconstructed fragments, faint, repeating waveforms embedded in radio static. The patterns weren't random. They showed mirrored symmetry, pulses separated by constant intervals. One waveform, when translated into audio, sounded disturbingly human, a low, rhythmic hum that rose and fell every 11 minutes and 12 seconds. It wasn't a message, not in words, but it carried structure, a pattern of modulation consistent with information encoding. The data was incomplete, fractured, but the shape was there, order inside noise. When the group published their findings anonymously online, the post was deleted within hours. Their cloud storage was locked by an automated DMCA request originating from an IP address traced to NASA headquarters. The takedown claimed unauthorized use of government telemetry. Meanwhile, a new kind of silence spread, not technical but human. Several senior researchers quietly resigned or went on extended leave. Conference sessions on 3I Atlas were canceled due to data availability. The public repositories stopped updating. Even the ephemeris tracker, normally automated, froze on the date of perihelion. In the vacuum, speculation flourished. Some claimed the missing data revealed proof of alien communication. Others said it showed the comet disintegrating into a magnetic cloud. The truth, buried in those vanished minutes, remained unknowable. But a few who had glimpsed fragments of the unredacted telemetry agreed on one point. Whatever occurred during the blackout, it wasn't simple energy transfer. It was exchange. In late November, Dr. Griggs wrote a final note to herself, never meant for publication. Open quote, "Every system went blind together. The sun, the probes, the ground stations, even independent sensors. Something pulsed through the entire heliosphere, a field resonance too uniform for nature. Maybe it was an erasure. Maybe it was concealment. Maybe for 10 minutes, everything was listening, and whatever it was, it wanted privacy." Close quote. Her note ended there. When the next batch of archived data was released to the public months later, the timestamps flowed seamlessly. The gaps were filled with synthetic interpolation, numbers so smooth they betrayed their artificiality. To anyone glancing casually, the event looked ordinary again. But the raw data, the real data, was gone. Between October 28th and 29 of 2025, the universe had gone silent for 12 minutes, and no one, not NASA, not ESA, not any nation or network, could say why. In those missing minutes, something had passed between the sun and 3 Atlas, and the instruments built to witness it had simply vanished from awareness, like eyes closing on command. The cosmos had blinked. And when it opened its eyes again, history had been quietly rewritten, leaving behind only the neat symmetry of silence, and a question that still haunts every scientist who ever saw the empty lines in those logs. What did we not see? Hypotheses in shadows. In the aftermath of the data blackout, the scientists left behind were divided, not by politics, but by terror. They had numbers that defied thermodynamics, telemetry that rewrote itself, and magnetic maps that bent like reflections in rippling water. None of it made sense under known physics. And when science loses its ground, speculation rushes in like a tide. Behind closed doors in encrypted group calls, anonymous forums, and whispered conversations between colleagues who no longer trusted their own institutions, a dozen competing hypotheses emerged. None could explain everything. Each carried its own kind of dread. The first was the inductive resonance hypothesis. It proposed that 3I Atlas wasn't acting alone, but had entered a pre-existing electromagnetic resonance between the Sun and Earth. In this view, the object was like a guitar string vibrating sympathetically when another string nearby was plucked. The Sun's surge, Earth's magnetic tremors, and the object's sudden flare were harmonics in a single, unseen system. Supporters of this model pointed to the 11.2-minute pulse, a frequency matching both solar Alfvén waves and deep Earth magnetic oscillations. If 3I Atlas had a conductive or ferromagnetic core, it might have tuned itself to the heliospheric field, amplifying certain frequencies until energy resonated across astronomical distances. The objection was simple: that much coherence across that much space would require synchronization at speeds faster than light. But resonance doesn't need transmission, it needs rhythm. As one physicist put it, if the universe already hums at that frequency, the object didn't cause it, it just revealed the song. Then came the dark plasma model, a more radical theory. It suggested that 3I Atlas wasn't composed of ordinary matter at all, but of mirror plasma, a hypothesized counterpart to normal matter that interacts primarily through gravity and magnetic fields. The idea came from fringe particle physics, where some theorists proposed that a shadow form of plasma could exist alongside visible matter, undetectable except when magnetically excited. If the object were made of such material, it could pass through magnetic boundaries without friction, yet still distort them slightly, like a ghost hand pressing on a drum. The brightness surge under this theory wasn't light reflected from dust, but a conversion event, dark plasma interacting with sunlight and momentarily converting energy into visible photons. Critics dismissed it as fantasy, yet one unexplained clue lent it fuel. The way 3I Atlas's luminosity changed faster than outgassing could allow, almost as if its surface responded instantly to fluctuations in solar wind. That reaction time implied electromagnetic coupling beyond simple heating. Something in its structure knew what the Sun was doing. Another camp whispered about the feedback loop hypothesis. In this view, the object, the Sun, and Earth formed a temporary closed system of energy exchange, a cosmic circuit. Each pulse strengthened the next until the system overloaded, leading to the blackout, an automatic self-regulation event. The missing minutes were the system resetting itself. To test it, one group modeled the interactions as coupled oscillators. The results were unnerving. Their simulations showed that if a conductive object entered the heliosphere during a solar magnetic reversal, phase locking could occur, briefly synchronizing the object's spin, the Sun's field, and Earth's magnetosphere. But the model also predicted instability. When resonance peaks, feedback causes all systems to dampen simultaneously, or crash into silence. The blackout fit that perfectly. A few dared to go further. They argued that the object's behavior looked less like passive resonance and more like response. The oscillations weren't just in sync, they were reactive, adjusting phase in real time. That implied intelligence, not necessarily conscious but organized, capable of pattern recognition. This became known half-jokingly, half fearfully, as the sentient comet hypothesis. Its proponents compared 3 Atlas to a self-regulating biosystem, something like coral or slime mold on a cosmic scale, able to sense magnetic gradients and adapt to them. Not alive as we understand life, but behaviorally alive. It consumed energy, reacted to stimuli, and maintained structural coherence under extreme radiation. If life can exist as chemistry, said one astrophysicist in a private message, why not as magnetism? The theory found eerie support in the object's chemistry. Its surface acted like a photoreactive semiconductor, converting solar radiation into modulated energy bursts. Biological or not, it behaved like a networked organism, absorbing, responding, releasing. Others preferred a simpler explanation: human error, data corruption, overinterpretation. But even they struggled with one detail: the blackout's global coordination. Computer bugs don't strike every probe, every satellite, and every observatory simultaneously. Something had synchronized the silence, which brought them to the most controversial idea of all, the signal hypothesis. According to this view, the blackout wasn't an accident, nor a system failure. It was deliberate. Not human, not random, but intentional interference. The missing minutes, the theory said, weren't missing at all. They were censored, not by NASA, but by whatever the instruments had captured. One researcher from Caltech, writing anonymously, described it like this, open quote, "Imagine an electromagnetic field so coherent it could induce phase locking in every sensor tuned to it. To us it looks like silence, but inside that silence, data continues, encrypted in the carrier wave." The instruments didn't shut down, they were repurposed. Repurposed. The word struck fear because it implied agency, that our machines had been used as receivers. When pressed, the theorist elaborated, the blackout corresponded exactly to the alignment of three Atlas, the Sun and Earth, 3 points on a straight line. That configuration, he suggested, could form a transient waveguide, channeling plasma oscillations like a fiber optic cable. For 12 minutes, information could have passed through, hidden in the magnetic flux itself. What kind of information? A journalist later asked him during a rare interview. He smiled. Whatever travels on the same frequency the universe already uses to talk to itself. Most mainstream scientists avoided commenting, but off record, a few admitted unease. If the blackout was a transmission, then our instruments, our eyes, had been blinded on purpose to keep us from seeing it. And yet, not everyone believed the agency lay beyond us. A smaller faction, the containment hypothesis, suggested the blackout was engineered by NASA or another agency, not to hide alien contact, but to prevent mass panic. According to leaked snippets, high-level communication networks did experience controlled shutdowns during that window. Could someone have overridden observatory systems under a national security directive? It would explain the precision, the identical durations, the rewritten logs. Still, that theory didn't solve the core problem. Why now? Why would the government suppress an event it could simply explain as a data glitch? Why erase when denial would suffice? Others pointed to a darker possibility, the recursive hypothesis, that the blackout wasn't caused by humans or by an external signal, but by the act of observation itself. Measuring the resonance had fed energy back into it, amplifying the interference until the system collapsed. In other words, the scientists themselves had triggered the silence. In physics, feedback loops between observer and phenomenon are rare but not unheard of. Quantum entanglement, for example, can decohere when measured. On a cosmic scale, the same principle might apply. Our sensors, designed to observe electromagnetic fields, had become part of the field. For a brief instant, the instruments, the data, and the object might have shared the same informational state. And when coherence peaked, everything equalized. Observation became participation. As one theorist wrote afterward, "We didn't just watch it, we joined it." Of all the shadow theories, none gained consensus. Each explained some fragment, none explained all. The resonance, the chemistry, the blackout, the timing, the silence. But across every hypothesis, a single thread ran constant. The idea that 3I Atlas wasn't random. Its arrival, behavior, and timing coincided too neatly with the sun's magnetic upheaval and Earth's weakening field. It came when our system was most susceptible, when the gates were open. A physicist from Kyoto summarized it best in a private email later leaked to the press. Open quote, "We treat the sun as a generator, Earth as a receiver. But what if they're both transmitters? And 3I Atlas was the tuning fork between them." Close quote. By December 2025, the hypotheses had become myth. Some scientists withdrew into silence, fearing ridicule. Others kept digging, haunted by what felt like unfinished communication. A few still met in encrypted chat rooms, trading scraps of data, believing that the blackout wasn't the end of the message, but its beginning, that the real transmission hadn't stopped. And though no one said it aloud, a quiet dread lingered over them all. Because if the blackout was deliberate, if those 12 minutes were protected space for something to speak, then the next question was unavoidable. When the silence ended, did it stop speaking, or did it start listening back? Opposing views. By early 2026, the debate over 3I Atlas had become a war of belief. On one side stood the institutional scientists, the solar physicists, orbital dynamicists, and data engineers who insisted that everything observed could, in principle, be explained within the framework of known physics. On the other side, a growing network of renegade researchers, independent observatories, and even a few insiders quietly defecting from official channels argued that something extraordinary had taken place. and that NASA, ESA, and the international scientific community were hiding it, either by design or by denial. The fault line ran deeper than just data interpretation. It was philosophical. The question wasn't only what happened during those missing 12 minutes, but what kind of universe allows it to happen at all? Official publications took a firm stance. 3I Atlas was an unstable interstellar body undergoing volatile sublimation. The observed resonance patterns were products of correlated measurement error, aliasing effects between instruments operating in overlapping time domains. The synchronized blackout across space agencies was attributed to cascading software updates triggered by solar interference. "We have no evidence of anything anomalous," said Dr. Martin Kell from NASA's Planetary Science Division during a press conference. "What we observed was the complex interplay of natural astrophysical processes, nothing more." He paused just long enough to sound rehearsed. The rebuttal came swiftly. Within 48 hours, a consortium of independent analysts published a counter-report titled Temporal Coupling Signatures in 3I Atlas Observations. It dissected NASA's explanations point by point. The supposed software updates occurred at different times in different systems, yet every blackout still overlapped within a 2-minute window. Their paper concluded that the probability of purely coincidental synchronization across international observatories is less than 1 in 100 trillion. Dr. Kell's response was curt. "The universe has plenty of 1 in a trillion events. We just don't notice most of them." But that line, the quiet appeal to coincidence, only deepened the divide. Because 3I Atlas wasn't an isolated anomaly anymore. By then, smaller ripples had appeared in unrelated data. Faint electromagnetic fluctuations recorded weeks later in the outer solar wind, shifts in the Schumann resonance, micro variations in the decay rates of certain isotopes on Earth, all with timing echoes that traced back to the October blackout. Coincidence was starting to feel like choreography. Inside research institutions, tension grew unbearable. Teams were forbidden from discussing cross-domain phenomena outside their specializations. Heliophysicists could talk about solar activity, but not about geomagnetic resonance. Astrobiologists were instructed to focus on composition, not correlation. The boundaries were drawn not to protect science, but to protect order. Privately, however, many scientists were slipping across those lines. Some under pseudonyms joined online forums, conversing with the very conspiracy theorists they once mocked. A few posted fragments of restricted data, waveform plots, magnetic field curves, timestamp comparisons, claiming they had a right to truth as citizens, not just as scientists. Others recoiled, appalled. "You can't build knowledge out of leaks," said ESA's communications director in a televised debate. "You build it from verification." "Then verify it," countered astrophysicist Ria Voss, the journalist-turned-researcher who had become the public face of the opposition. "Release the missing data sets. Show the world the full spectral logs." They didn't. The official position hardened. NASA issued a formal review under the Scientific Integrity Directive of 2026, reaffirming that no credible evidence supports any causal relationship between 3I Atlas and solar, geomagnetic, or temporal anomalies. It was bureaucracy phrased as closure, but the leak networks called it something else: the silence strategy. The institutionalists. The traditionalists held the line for one reason: they feared losing science itself. To them, acknowledging even the possibility of magnetic coupling or non-natural coherence risked detonating centuries of rational structure. They invoked Occam's razor of repeating that extraordinary claims require extraordinary evidence. "Nature is weird enough," wrote Dr. Armitage from Caltech. "You don't need intelligence in your equations to explain complexity." He and others pointed to historical parallels, how earlier anomalies like the Pioneer spacecraft's unexplained deceleration were eventually traced to mundane factors such as heat recoil. They predicted 3I Atlas would follow the same path. They emphasized how easily human perception invents patterns. During active solar cycles, data streams overflow with spikes, dips, and harmonics, thousands of random fluctuations. Align any subset of them with a comet's behavior, and coincidences multiply. "You could find rhythm in a rainstorm if you stare long enough," said one skeptic during a podcast debate. Still, the institutionalists couldn't explain away the most uncomfortable evidence: the synchronized loss of telemetry. Instead, they redefined it as a data logging synchronization artifact caused by timestamp drift. In simpler terms, all systems happened to glitch at once. That explanation satisfied committees, but not the people who had seen the raw feed cut to static. Some insiders clung to a middle ground. They admitted the anomalies, but argued for unglamorous causes: unknown solar feedback loops, charge accumulation on sensor panels, cosmic ray interference. Anomalies don't mean intelligence, said Dr. Patel from the Indian Institute of Space Science. They mean ignorance. Something happened we don't yet understand, but that doesn't make it supernatural. Yet his words rang hollow to the engineers who had watched their instruments reconfigure themselves mid-event. Ignorance was one thing. Apparent self-awareness was another. The reformists. The reformists, those who believed the event had revealed something profound, saw the institutional caution notice but as cowardice. To them, the blackout and its synchronized timing represented a paradigm shift, a glimpse of an interconnected universe where magnetic fields and information were inseparable. They began publishing under pseudonyms, framing 3I Atlas not as a comet but as a magneto-informational structure, a natural transmitter bridging systems through resonance. Some even described it as a cosmic neural node, part of a larger network of self-organizing plasma entities. To the establishment, it sounded like mysticism dressed in math. But to the reformists, it was simply the next frontier. Their writings circulated in encrypted archives and digital zines. One essay titled The Heliocentric Circuit Hypothesis argued that the Sun, Earth, and interstellar visitors form a triadic communication system. Energy and information are two expressions of the same geometry, the author wrote. The blackout wasn't silence, it was handshake protocol. Critics mocked them as cultists, yet some reformists were anything but fringe. Several had backgrounds in plasma physics, quantum field theory, or space engineering. Their credentials lent the movement a dangerous legitimacy. They weren't anti-science, they were post-science, while building models that the institutions refused to touch. Among the most compelling reformist voices was Dr. Nia Rhodes, once a respected NASA solar physicist, now unofficially exiled after leaking magnetic resonance data. She claimed 3I Atlas demonstrated magnetic intentionality, a measurable preference in alignment behavior not caused by gravity or gas pressure. It's the difference between drifting and aiming, she said, and this object aimed. Rhodes believed 3I Atlas was part of a broader pattern, the third in a series of interstellar probes exhibiting similar anomalous acceleration. Oumuamua was the first knock, she told an independent documentary. Atlas was the reply. Her detractors ridiculed the phrasing, calling it poetic nonsense. But her findings were harder to dismiss. When her team modeled 3I Atlas's path backward, they found it intersected the trajectory of Oumuamua within half a degree, an astronomical coincidence too close for comfort. If true, it meant both visitors might have originated from the same source. What if it's more than a comet? There's a moment in every mystery when the line between science and story begins to blur, when evidence doesn't just fail to explain, but begins to suggest. By December 2025, 3IAS had become that kind of story. The kind where every official assurance of natural phenomena only deepened the suspicion that something else was at play. The phrase began as a whisper among astrophysicists trading encrypted messages. What if it's more than a comet? Not metaphorically, literally. Because by every measure, 3I Atlas had stopped behaving like an inert body long before it reached perihelion. It moved with precision, reacted to fields, and released bursts of energy that looked suspiciously deliberate. Even its composition, what little data wasn't scrubbed, defied expectation. The ratios of magnesium to silicate didn't match any known interstellar dust. And embedded within its faint emission spectrum were discrete, repeating peaks, evenly spaced like the teeth of a coded signal. Comets don't broadcast in intervals, machines do. Still, the idea that it could be artificial was too radioactive to say out loud. Most scientists who flirted with the notion buried it under euphemisms: coherent structure, reactive surface, non-random albedo modulation. But those phrases all meant the same thing: control. Something about 3I Atlas behaved as if it was aware of its environment. The data blackout only fanned the flames. The precision of those missing minutes, 12 across multiple systems, felt less like technical failure and more like intermission. And when instruments came back online, they showed signs of subtle reconfiguration, not damage, adaptation. The telemetry files suggested that, for a brief window, the spacecraft watching it had been influenced by something external, something that rewrote how they recorded reality. To engineers, that possibility was heresy, but to the few who had seen the raw data before it disappeared, it was the only theory that fit. One analyst described it bluntly: whatever it was, it touched our machines like fingers through static. Then came the revelation from the infrared arrays. Buried in the heat signature data was a pulse, regular, symmetrical, too consistent to be geological. At first, analysts thought it was a glitch, but the pulse repeated at exact intervals, 11.2 minutes, the same cosmic rhythm that had haunted the event from the start. Over the course of 2 days, the amplitude of that pulse shifted gradually, almost like calibration, an object testing the frequencies of its environment. For a comet, that's meaningless. For a transmitter, it's the definition of intent. Still, intent requires structure. And so far, telescopic images showed nothing but a tumbling nucleus wrapped in gas and dust. But one image taken by the solar orbiter and leaked through unofficial channels told a more complicated story. In the frame, low contrast, blurred by solar glare, was a faint geometric lattice glinting inside the coma. Too linear for natural fracture, too symmetrical for chance. Engineers dismissed it as compression artifact, a digital ghost created by image processing. Yet when the frame was enhanced, the pattern resolved into something resembling a mesh, an open framework, not unlike the honeycomb struts used in spacecraft radiators. The dimensions, if real, would make it nearly 50 kilometers across. That image was never officially acknowledged. The file name IA3-251029-CQ11.TIFF was quietly removed from ESA's servers within hours of its discovery. But by then, copies had already circulated. Even after digital forensics ruled it inconclusive, few could forget the shape that shimmered faintly behind the dust, a scaffold of order inside chaos. It was enough to fracture what remained of consensus. The debate no longer centered on whether something unusual had occurred, but what kind of unusual. One school, the cautious optimists, suggested 3I Atlas might be a natural interstellar relic that behaves like a transmitter by coincidence. Maybe its structure trapped charge as it rotated, acting like a massive capacitor that discharged rhythmically under solar stress. Others proposed a self-sustaining plasma shell, a natural electromagnetic organism of sorts feeding on sunlight and magnetism. But a bolder faction began whispering something else entirely, that 3 Atlas was never a comet, that it was a vessel. The evidence, fragmented as it was, had a pattern. Its brightness fluctuations followed harmonic sequences. Its spin rate changed in ways consistent with vector correction, and its path through the ecliptic, the way it aligned almost perfectly with Earth's orbital plane, suggested intentional navigation. In one unverified leak, an internal memo from NASA's Planetary Defense Coordination Office described a series of non-gravitational corrections consistent with controlled trajectory maintenance. The wording was deliberately cautious, yet the phrasing alone implied maneuvering. A natural object drifts, a controlled one adjusts. If true, the implications were staggering. For the first time, humanity might have observed not a signal, but the signaler itself. Skeptics countered with predictable vehemence. They warned against the anthropocentric trap, the tendency to interpret natural complexity as evidence of intelligence. Lightning, after all, had once been mistaken for gods. We project purpose onto patterns because we fear randomness, one physicist argued. But others pushed back. What if the opposite was true? What if the universe was structured by patterns that are purposeful, but we've trained ourselves to dismiss them because acknowledging design feels too dangerous? Even the skeptics couldn't explain the timing coincidences, the eerie way the object's energy pulses matched fluctuations in solar output, and how those pulses in turn corresponded with minute tremors in Earth's magnetic field. It was as though the three systems, Sun, Earth, and 3I Atlas, were parts of one circuit, resonating across scales. And circuits, by definition, transmit. That's when whispers began circulating of a darker theory, that the object wasn't communicating with us, but through us. In this model, the blackout wasn't an act of secrecy, but of synchronization. The object had used the Sun's magnetic field as a carrier wave and Earth's magnetosphere as a receiver. The instruments didn't fail, they participated. The data loss wasn't absence, it was conversion. This idea, terrifying as it was, explained something no other theory could: the uniformity of the silence. Every instrument, no matter how isolated, ceased functioning simultaneously. That kind of coherence requires one thing only: shared resonance. What if 3i Atlas had triggered a state of temporary coherence between all magnetic systems in range, including Earth's? What if, for 12 minutes, everything synchronized to the same frequency, and we, for once, weren't the observers, but the medium itself? Among those few who dared speculate further, the question took on existential tones. If the object was intelligent, its behavior seemed almost diagnostic: probing, measuring, calibrating. But calibrating for what? Contact? Transmission? Or something more complex, something preparatory? There were rumors, unconfirmed, impossible to verify, that deep space radio observatories had detected low-frequency murmurs days after the blackout, signals that matched the modulation period of the lost data. Most were dismissed as interference. A few, however, originated from a direction inconsistent with any known source. Not from the comet, not from the sun, but from interplanetary space along the same vector behind Earth's orbit. It was as if the signal had passed through us and kept going. Some took that as proof of alien communication. Others saw it as something far subtler, a natural cosmic function we'd never recognized before, a kind of universal feedback loop that occasionally manifests when the right geometry, energy, and timing converge. A few even dared to describe it in almost spiritual terms, calling 3i Atlas a mediator, a bridge between stellar consciousness and planetary life, not sentient in a human sense, but operating on a scale where energy itself carries awareness. Those words made traditional scientists recoil. Yet they captured something the data couldn't deny: the sense that, during those 12 minutes of silence, something looked back. Not with eyes, but with understanding. When the object finally dimmed and receded toward the outer system, it left no debris trail, no tail, no residual dust plume, nothing. It departed as cleanly as it arrived, leaving behind only altered telemetry and the faint hum that instruments continued to pick up for weeks. A soft rhythmic oscillation buried in cosmic background noise. To some, that hum was interference. To others, it was the last whisper of a system closing its channel. Because the most haunting question wasn't whether 3i Atlas was artificial or natural, alien or cosmic, intelligent or instinctive. The question was why it had chosen now, the peak of solar cycle 25, the exact moment of magnetic chaos, to reveal itself. If its purpose was to test the system, the timing was perfect. If its purpose was to communicate, it succeeded, by making us listen harder than we ever have before. And if its purpose was something else entirely, something we can't yet define, then maybe it was never meant for us at all. Because sometimes the universe sends signals not to its inhabitants, but to itself. And maybe for those 12 missing minutes, humanity simply stood in the middle, accidentally overhearing a conversation between stars. Ripple forward. When 3i Atlas finally faded beyond the orbit of Jupiter, its light curve flattening into statistical silence, the world thought the story was over. The news cycle moved on. The agencies stopped holding briefings. The feeds of the once obsessed astronomers went dormant. Yet, in the weeks that followed, strange aftershocks began to ripple outward, not in space, but here, on Earth. The comet was gone, but something had stayed behind. The first signs appeared in the magnetometer networks. Even after the sun returned to relative calm, the baseline of Earth's magnetic field didn't settle back to normal. It vibrated, subtly, rhythmically, at 0.0015 hertz, the same 11.2-minute interval that had defined the 3i Atlas resonance. It was too weak for anyone to feel, but the instruments heard it, a ghost pulse threading through the planet's magnetic heart like the faint memory of a song. At first, researchers dismissed it as residual noise from the solar storms of October, but as the months passed, the pulse didn't fade, it strengthened. Stations in Finland, South Africa, and Chile recorded identical oscillations synchronized to the millisecond. It was global coherence on a scale no natural post-storm relaxation could produce. Then came the auroras, small at first, barely visible beyond polar latitudes. But unlike typical auroras, these didn't follow solar wind patterns. They appeared during periods of solar quiet, sometimes in two hemispheres at once, glowing faintly with an unusual spectrum, a pale emerald core fringed with white-violet edges. When spectrographs measured them, they found an emission line that didn't match oxygen or nitrogen. The unknown line pulsed in time with the residual frequency. To the public, it was beautiful. To scientists, it was terrifying. It meant the Earth's atmosphere was responding to a rhythm not driven by the sun anymore, but by something internal, something that had been set in motion. The ripple didn't stop there. In early 2026, satellite operators noticed intermittent glitches in orbital telemetry. Clocks aboard GPS satellites drifted by nanoseconds at regular intervals. When those offsets were plotted over time, they formed a waveform, again 11.2 minutes per cycle. The same pulse that once echoed between sun and comet was now ticking quietly in the sky above Earth. It was as if the planet had inherited the frequency. Within NASA, a small task group was reassembled to study the anomaly, this time under a different name, the Geomagnetic Coherence Monitoring Initiative. Officially, it was about refining predictive models for auroras. Unofficially, it was about figuring out why the planet's magnetic core had started humming to an alien tune. Reports leaked quickly. One, dated February 2026, described a low-amplitude, planet-wide standing wave within the geomagnetic field, consistent with harmonic memory effects. That phrase, harmonic memory, spread through the scientific underground like wildfire. What kind of system, they asked, could remember a resonance after the source was gone? The leading theory was unsettlingly simple: energy retention through global induction. During the blackout, Earth's magnetic shell may have absorbed an external signal, storing it like a charged capacitor. Now it was slowly discharging, not as energy, but as pattern, a coded oscillation, invisible yet persistent. If that was true, the implications were profound. It meant the planet had become part of the circuit. Meanwhile, other phenomena began surfacing. Deep space radio telescopes detected low-frequency murmurs that mirrored the same timing signature. They came from multiple directions, too diffuse to triangulate. Some believed they were echoes of the original transmission bouncing through the heliosphere. Others suspected something more organic, that the resonance had spread, igniting sympathetic vibrations across the magnetic fields of other planets. Evidence soon supported the latter. Jupiter's magnetosphere, monitored by the Juno probe, exhibited faint modulations in field intensity at identical intervals. So did the magnetotail of Saturn. Even the thin, fragile field of Mars flickered in time with the same pulse. The synchronization was weak but real, an entire solar system trembling in subtle harmony. By spring 2026, the phrase solar system scale coherence appeared in classified memos. Few believed it at first, but the data wouldn't stay buried. Amateur astronomers began noticing unexpected brightening in the dust lanes near the ecliptic, patches of interplanetary medium fluorescing faintly when the pulse peaked. It was as though invisible waves of magnetism were sweeping outward, illuminating the cosmic dust like bioluminescent plankton stirred by unseen tides. The ripples weren't confined to physics. On Earth, strange correlations began appearing in human technology. Telecommunications companies reported synchronized packet delays across global networks. High-frequency trading servers in New York, London, and Tokyo experienced micro-latency spikes that matched the 11-minute rhythm. Clocks based on cesium oscillations, the most stable timekeepers humans had built, showed faint oscillatory drift. The world's artificial systems had started breathing with the same hidden cadence. Conspiracy theorists took it as proof of contact. Governments called it atmospheric interference. But one quiet paper, circulated anonymously among signal engineers, offered a third possibility. The pattern resembles a background handshake, a timing beacon, not a message, a system ensuring coherence among participating nodes. If that was right, then the ripple wasn't just a remnant, it was a synchronization protocol, something establishing alignment. The question was, alignment with what? NASA tried to get ahead of the narrative with another press release, this time couching the anomalies in the language of space weather. Persistent low-frequency oscillations, it said, are consistent with natural resonances following the peak of solar cycle 25. But even their own charts betrayed the lie. The sun's cycle had already begun declining, yet the signal was getting stronger. Within the agency, quiet panic resurfaced. Memos revealed deep disagreements. Some wanted transparency, others feared geopolitical fallout. If the signal had an external origin, every major power would scramble to weaponize it. And if it was internal, emanating from Earth itself, then the rules of planetary science were already obsolete. Outside the institutions, civilian researchers pressed forward. The Project Echo Collective, reborn under new aliases, reconstructed a rough model of the resonance field using open magnetometer data. The result was breathtaking, a global standing wave with nodal lines crossing precisely at tectonic boundaries and high-voltage transmission corridors. The energy wasn't destructive, it was subtle, almost architectural, shaping flows of electromagnetic potential around the planet like the invisible ribs of a shell. When visualized in 3D, the pattern resembled something eerily familiar, a spiral unfolding from the poles, curling along the equator, expanding outward. It was the same geometry traced by 3I Atlas's inbound trajectory. Coincidence, perhaps. But coincidences had built this mystery from the beginning. Then came the first biological anomaly. Medical research satellites tracking electromagnetic exposure on astronauts noticed elevated neural coherence when the pulse peaked, brainwave harmonization across individuals separated by thousands of kilometers. Later, similar effects were reported on Earth. EEG studies found faint synchronization in alpha and theta bands at intervals corresponding to the geomagnetic wave. It was small, barely measurable, but consistent. Humanity, unknowingly, had begun to hum with the same rhythm as the planet. Most dismissed it as statistical noise, but a few neuroscientists saw potential. If external fields can modulate global brain rhythms, one paper suggested, the implications for collective cognition are profound. Another put it more bluntly, we may already be part of the network. In July 2026, the resonance reached its first measurable peak, and auroras appeared simultaneously across both hemispheres, an impossible symmetry. Satellites captured a faint burst of radio emission rising from Earth itself, directed outward into space. The planet had responded. It had answered back. For 42 seconds, that signal pulsed steadily, encoded in narrowband frequencies just below the ionospheric cutoff, too precise to be random, too brief to be human. Then it stopped. No one could explain it. The official line described it as ionospheric ringing. But deep inside NASA's heliophysics division, a classified note circulated with one haunting sentence. The Earth transmitted at the same frequency that silenced us in 2025. After that, the resonance began to fade, slowly, gracefully, like a bell still vibrating after the hammer has lifted. By year's end, the field quieted, leaving only faint tremors buried beneath normal geomagnetic noise. But those who had monitored it knew what they'd heard. The planet had learned a pattern, and patterns, once learned, don't vanish. Some believed it had been a conversation. Others thought it was a natural resonance misunderstood as intelligence. Yet even the most skeptical admitted something irreversible had happened. The Earth's field was no longer the same. The sun's magnetic structure showed subtle reorganization, as if rewired. The space between them felt alive with faint, structured whisper. In the months that followed, a handful of probes launched to chase 3 Atlas's outbound trajectory. None found it. The region where it should have been was empty. No dust, no debris, not even ion traces. It had disappeared completely, as though phase shifted out of normal space. But the signal, its rhythm, its signature, remained faintly embedded in background radio noise. Amateur astronomers could detect it with modified receivers, a steady, gentle pulse repeating every 672 seconds. The same length as the blackout. No message, no voice, just the echo. Some say it's fading, others claim it's growing stronger again, synchronizing with the early stirrings of solar cycle 26. Either way, one truth endures: the universe remembers. And somewhere, far beyond the edge of light, 3I Atlas drifts in perfect silence, its trajectory untraceable, its purpose unknown, while the pulse it left behind keeps moving through everything. Through storms, through machines, through human thought itself. A reminder, perhaps, that we were never isolated observers in the cosmos, but part of a circuit vast beyond comprehension. A ripple still traveling outward, and maybe one day, returning.